So, hello, a very warm good evening to all of you. A confirmation about the audio, please. If the audio is clear and available, kindly confirm the same. Thank you. Sadhana, it is not that exactly at 4 degrees Celsius is where the water temperature will be at the bottom, but it will be close to around 4 degrees Celsius. And that has got two reasons associated with it. One of the reason that is associated and is linked with it is basically the impact of pressure of water also induces some amount of heat. We do know that greater the pressure, greater is the amount of heat produced. So that ensures a maintenance of temperature. And also, water has got its maximum density at around 4 degrees Celsius. If you cool water beyond 4 degrees Celsius, if you take it to 1 degree Celsius or 0 degrees Celsius, it tends to expand. But at the bottom of the ocean floor, water doesn't have any scope to expand because of the overlying pressure. Hence, you have the temperature which is maintained. Why there is high evaporation in the tropics? So see, when you consider only the rate of evaporation, there is not much of a difference between the tropics and the equatorial region. Even though in the tropics you will find slightly greater amount of evaporation, that is because all the tropical areas that you will observe, especially in the northern hemisphere, they are surrounded by landmass and they get heated to a significant extent. Whereas when we talk about the equatorial area, the temperature is moderated because of continuous rainfall. And that doesn't happen in the case of the tropics. In the tropics, you have the subtropical high pressure belt. So that is where the temperature doesn't get moderated. It keeps on getting higher and higher, and hence greater rate of evaporation. Farhat, talk Hindi also. See, first of all, understand that there are many in the session who are not very comfortable with the language. So you have to understand that this is an English session. It is not a bilingual session. Had it been a bilingual session, then maybe we could have had an interchange of Hindi and English. Yesterday, also, one of you had requested that to try to use more amount of Hindi language. But you have to understand that not all of the students present here are comfortable with that. So we have to go as per the requirements of the session. Okay. And also, I would advise you as well, if you are appearing for the examination in English, there is no reason why you should not be developing your skills in that particular language. And that is one of the issues which happens, because many of the times we get so very comfortable with the bilinguality that when it comes to writing, that is where we commit a lot of grammatical errors, grammatical mistakes. Our vocabulary doesn't develop, and we also generally lack a sense of confidence when we are confronted with the interview board or interview panel. And if you start stammering and if you start thinking about words at that point of time, then it doesn't put a particularly good reflection on you. Okay. Recurving of cyclone is basically due to the Coriolis effect. When the cyclone starts bending and curving, and it is carried by the permanent wind system, and then it starts bending and curving due to the condition of the Coriolis force. And because it is a circular motion, that curving gets exaggerated. That is recurving. Okay. Okay. Lakshya, it is not only the aspect of, see, if naturally there is an issue while speaking, fair enough. But it gets very clear whether someone is confident over their language skills or not. And at the end of the day, you will find that in general, People who are very confident with their language skills, they are rewarded in the interview. That is why it is often time advised that choose a language that you are comfortable with and approach the interview with that. Benika, why are more deserts in western coast of continents? We will discuss that when we talk about the ocean currents, the cold ocean currents, etc. Okay. So today we start the discussion with the portion of tides, and then we will move ahead with the understanding of ocean currents. We'll take a look at the ocean currents which are in existence in all the three different types of oceans, that is the Atlantic, the Pacific, as well as the Indian Ocean. We'll try to get an inkling that what are the basic fundamentals depending upon which the ocean currents they do come into existence. What are the classification of ocean currents? And basically it is as simple as, once you understand the basic of one ocean, that how the ocean currents they come into existence, you can apply the same model in the other oceans as well, and you will get a clear cut idea from that as well. Now after that, we shall be taking a look at the corals very briefly, the geographical aspect of it, and then we will take a look at the PYQs which have appeared from this particular area. Okay. So here, first of all, we start with the aspect of tides. So yesterday we had discussed about the wave motion. And in the case of the wave motion, we had discussed that how, due to the movement of the winds, oftentimes the water is carried slightly upwards and then it falls because the wind is unable to carry it further along, and then it falls. So there is a kind of a circular oscillatory motion which is induced in the water. And that is where you have the formation of the crest, and that is followed by a trough. Again, the region where you observe the crest, that will be the region where you will observe a trough next time. So that keeps on changing, forming the wave pattern. But when we talk about tides, tides are something completely different. It is a different matter altogether, that many of the times in the common language and in the common reference, you will find that people end up interchangeably using the word tide and wave, but they are very, very different. In the case of the waves, you had a kind of an undulation of water, and there water would rise up, fall down, move ahead, come back. So there you had the localized movement of water. But when we talk about tides, this is when the height of the water body, that is the oceans, the seas, not the rivers, lakes, and ponds. And please don't compare it that you said water body in my backyard, the river is so very big, it is like a sea, so it will also observe the same. No, it is observed in the case of seas and oceans, where almost twice a day the sea level rises significantly and then again falls down significantly. So there is a kind of a rise and also a fall which is induced in the sea level. So that rise and fall which is induced in the sea level, that is what we refer to as the tidal movement. Okay, so vertical motion refers to the rise and fall of water in the oceans and the seas. Now, this in itself is driven by two forces. There are these two forces which are responsible for inducing the tidal movement across the planet. And which are these two? So one is the gravitational pull of the exerted by the sun and the moon, what is also referred to as the tidal force. And the second is what we refer to as a centrifugal force. As the planet rotates, there is a centrifugal force which acts around the central portion. So here, a combination of these two forces leads to the uplift and the downfall of the water level, and that happens periodically. It generally happens that you will observe twice a day the rise of the water level, twice a day a fall of the water level as well. So what is it that happens? How is it that actually it pans out? Let us take a look at it. So when we talk about the forces, so first of all, let us write these forces, the two forces responsible. One is the gravitational pull of sun and moon. And second is the centrifugal force due to rotation of planet. Okay, so these are particularly the two forces which are responsible. So here, when we take a look at the gravitational pull, so as the planet Earth moves, you have a gravitational pull which is induced by the moon as well as induced by the sun. So here, think about it. Suppose here you have the planet, right? Here is where, let's suppose you have the moon, and let's suppose you have the sun here. Okay. Now, this is the planet rotating continuously from a direction of west to east. Here you have the moon, here you have the sun, here you have the earth. Now, they will extend their gravitational pull of attraction. Now, gravitational pull of attraction is not so strong that it will be able to pull the planet Earth itself. But let's suppose we consider the presence of water body, and we consider the presence of water body all around the planet. So here, if you think about the water body which extends all across the planet, here we are talking about the continuity in the form of oceans. Okay, let's suppose. Now here, you will observe that because of the gravitational pull which is exerted, which is subtended, you will observe that while the planet in itself cannot be impacted at large, but that gravitational pull is enough to create a tidal bulge, a kind of a bulge. Right? So sun will create its own bulge, moon will also end up creating its own bulge. Now moon can be present in various different places. Moon can be present here as well, moon can be present here as well. So wherever the moon is present, it will induce a kind of a tidal bulge. Now that tidal bulge is induced due to the gravitational pull of attraction. Right? So let's suppose the moon comes from this position to here. Let's suppose. Then the bulge created by the moon will also end up shifting. The bulge exerted by the moon will also end up shifting and getting disturbed ever so slightly. So here you will observe that the bulge basically here you will observe that the bulge created, let's suppose the moon has come here in this particular position. So here you will observe that the bulge gets exaggerated here. This is the lunar bulge. Okay, lunar bulge as in created by the moon. Whereas the sun will also have its gravitational pull of attraction. So sun will also be impacting the water in terms of the gravitational pull of attraction. Oftentimes, it is a resultant between these two gravitational pulls of attraction, which induces a variation in the water level in terms of their height. So that is why whenever you must have been to a, let's say, coastal area, you would have observed that generally in the afternoon, that is roughly around 2 p.m. or 12 p.m. in certain places, 2 p.m. in certain places, you will observe it is a condition of a high tide. The coast guards, or rather the lifeguards who are present across the beaches, they don't allow you to get into the water because the water level rises. And then again at around 6 p.m., around 7 p.m., you have the water level which falls. Again at around night, that is 12 at night, 1 at night, or 2 at night, again the tide rises. And then again early in the morning, the tide tends to fall. So that is the variation. And that variation is induced by the presence of this gravitational pull of attraction. So here, that is one of the factors. The other factor is, so here is the creation of a tidal bulge due to gravitation. Tidal bulge due to gravitation. So observe here, due to the presence of moon, you will observe due to the presence of moon, the water level rises up in this region. Now, if the water level rises up in this region, where will the additional water come from? Is it that in those areas suddenly you will have more water which is present and hence it has risen up? No, that water will be drawn from the surrounding regions. So, in the other areas from where you draw that water or where the water is driven from to accumulate in these bulged portions, so that is what we refer to as the high tide and the low tide. So here you will observe that wherever the water has accumulated and the height has increased substantially and significantly, because of, here you will observe that water has accumulated here coming from all these portions. So that is where you will observe that in these regions, the water level has actually gone down in these particular places to account for the rise in water level observed in these areas. Okay, so that is where these areas will receive low tide and these areas will receive high tide. Now, let's suppose after some time, the position of the moon comes here. Let's suppose now, once the position of the moon comes into that area or that territory, what will be the condition? So here you will observe the bulges to be present here. The bulges to be present here. So if the bulge now has shifted here, so this will be the region of high tide, right? And these are the areas from where water is drawn up. So that will be the region of low tide. Then again, when the moon, let's suppose, comes here, it will again be a repetition of the first scenario where you will have a bulge here. You will have a counter bulge on the other side to gain equilibrium, and then you will have low tides in these areas. Again, if let's say the position of the moon is here, so again you will have a repetition of the first scenario where you second scenario where you will observe that the bulge is created according to the position of the moon. Generally, you will find that the gravitational pull induced by the moon, that is much more powerful in terms of the tidal effects as compared to the gravitational pull induced by the sun. Why? Even though sun is much larger, even though sun has got much greater amount of mass, but the tidal force induced by the moon is much more powerful because moon is much closer to the planet earth as compared to the sun. So hence, when we talk about it here this is more dominant. Very good, beautiful guys. More dominant due to the proximity with planet earth. Okay, gravitational pull is determined, or gravitational force is determined by the, or it is a sum product of the mass as well as the distance between the objects. So in the case of the moon, the mass is small but the distance is also very less, whereas in the case of the sun, the distance is much larger. Now after this, you have another impact, that is the centrifugal force. Now what is a centrifugal force, guys? Now, you would have, or we have already studied about the portion of the centrifugal force earlier when we had a discussion about the continental drift theory. So here you have the, what do we understand by centrifugal force? So centrifugal force is what? So when any object moves in a kind of a circular motion, any object. when it continues to move in the circular motion. There are two forces acting on that object. One is the force which pulls it towards the center, what we refer to as centripetal, and there's a force acting away from the center that is referred to as centrifugal. This is the force acting away from center in the case of a rotating object. You would also have experienced this. I will again take the same example which I had taken it earlier while we were discussing about the continental drift. Let's suppose you have a ball, right, attached to a string. Now, if you hold that string and start rotating that ball continuously in a circular motion, you will feel the force where the ball tends to move away from you. It tends to fly away from you as you increase the speed of rotation. So why is it that the ball tends to move away from you? That is the force which we refer to as the centrifugal force. So here, when we talk about, let's say, the planet in itself, now we do have the sun, okay, and you have the planet Earth, which rotates around the sun in an elliptical orbit, right? The planet rotates around the sun in an elliptical orbit. So this is also like a circular motion in the indeed, right? Here you have the sun, here you have Earth. So the planet also is rotating continuously here in a circular motion. So there will be a centrifugal force acting away from the center, isn't it? That centrifugal force which is acting away from the center, while it is nowhere that strong that planet Earth in itself will be pushed out of its circular orbit or the elliptical orbit, but it has got enough power to disturb the presence of water. So here, when you take a look at the water, it will develop a slight bulge in the opposite direction. Okay. So you have one bulge created by the force of gravitation, the other bulge created by the centrifugal force. A sum product of these two, they end up inducing the condition of the tidal bulges or the tidal movement. So here, if you take a look at it, centrifugal force, these are responsible, so including the force of gravity by the sun and the moon. So these two are responsible for creating two major tidal bulges. The tide generating force is the difference between these two forces, that is the gravitational attraction of the moon and the centrifugal force. So in order to simplify it, take a look at the schematic diagram. So here you have the tidal bulge created by the force of gravitation, the first image that you see. The second image that you come across, that is the bulge, tidal bulge created due to the centrifugal force. A sum product of both these two, that will end up creating the tidal movements and variation across the planet. And you have to understand that the planet is continuously rotating as well. So if one place is experiencing a bulge, next time some other place will experience this, and it keeps on changing through the day. Okay. So that is about the tidal movement. Now, these tidal movements, they basically are induced by the position of the sun and the moon, and that impacts the kinds of tides as well. So you have the classification of tides which is done based upon the position of the sun and the moon, right? If the position of the sun and the moon, let's suppose sun, obviously in comparison to planet Earth, sun is almost fixed, whereas the moon keeps on moving, right? Moon will have its own movement thereafter. So if I can use another image, and in order to simplify it, if I can use another image here, so position of sun and moon. Okay, all those who are asking why the opposite side develops a kind of a bulge, that is what is also referred to as a counter bulge. Okay, many of you have asked this question. I just took a look at it. So many of you have asked this question, that why is it that the opposite side develops a bulge in the case of gravitational pull? So that is a counter bulge, what is referred to. And that is in order to gain that symmetry. Planet Earth is a rotating object, and that is why in order to gain that equilibrium, there is a kind of a counterbalance as well. And that counterbalance develops a bulge on the other side. Okay, I hope that is understood. Right? Now, here, can we come to the position of sun and moon, or is there any other issue? About the portion of lunar eclipse, don't worry about it. We'll come to it. This is the portion that we are talking about. This is the portion that we are going to elaborate upon. Okay. So here, let's suppose you have the sun. Here. Now, let's have the planet Earth here. Okay. Let's have a the case of, let's consider the case where the sun induces a gravitational pull and a tidal bulge is induced by the sun. So due to the position of the sun, there will be a tidal bulge created here in this position. I hope you are able to understand that basically the sun will induce this kind of a gravitational pull on its own, and this type of impact completely on its own, right? So this, let's call it the solar bulge, or the tides created due to the position of the sun overall. Now here, let's suppose you have the position, or you consider the position of the moon as well. Let's consider the position of moon. Let's use another color. So let's consider the position of moon to be somewhere here. Now, the lunar bulge which will be created, which will be significantly more powerful. The lunar bulge will always end up having a greater amount of gravitational pull because of the proximity to the planet Earth. It is nearer to planet Earth, so the gravitational pull will be more, isn't it? So here you will observe that basically, let's assume, so you will have a bulge created here. Let's suppose roughly this ends up representing the bulge created by the moon, or the lunar bulge. Okay. This is your solar bulge. Now, as per the condition here, moon has induced a high tide here, but then as per the condition or the position of the sun, the water should be lower. Then as per the position of the sun, the water should be slightly higher here. The water should be comparatively lower due to the position of the moon. So that is where the lunar position is more dominant in deciding where you will have the high tide or low tide. It can end up canceling the position or the impact of the sun, or it can end up exaggerating or adding on to the impact of the sun. So let's suppose the moon is here in that situation. In that case, both the lunar and the tidal bulge will be existent in the same place. Okay. Here, both of them will be existent in the same place. So the high tides will be higher than average, low tides will be lower than average. So that is how you have the classification of tides based upon the position of the moon and the sun. So here, when you take a look at it, you have the basic classification that sometimes it happens that the sun, the moon, and the earth, they are across the same line, or the same plane rather, right? So they might not be collinear with each other, they might not be in the straight line, but they might exist in the same plane. So in that case, when they are in the same linear position, that position of the sun, moon, and the earth, that position is referred to as syzygy. here the first image that you look. In the first image, you will find that moon and earth and sun, they are lying across the same plane. So this position is referred to as syzygy. Okay. Now, here you will observe that the solar tide will add on to the lunar tide here, isn't it? The solar tide and the lunar tide, they will complement each other. So they will be observed in the conditions when you have the new moon, when you have the full moon. In both these conditions, when you have the position of the moon at the same plane as compared to the earth and the sun. So they will add on to each other. So in this position, there is another classification of this position, not very much required for your general studies, but something that you should know. So here, let's suppose you have the moon in between the earth and the sun. That position is referred to as conjunction. Conjunction. When you have the moon on the opposite side, and on both sides, one side you have the moon, other side you have the sun, that is what is referred to as opposition. This is your opposition. Okay. So you have the conjunction and opposition. Now these are all the positions which are regarded as syzygy. Now in this position, what do you experience? What do you think will be the height of the high tide? The high tide, will it be higher than average? Will it be lower than average? What do you think will be the position of high tide? Higher than average, right? So this is where high tides, this is where we experience spring tides in general. So in the case of spring tides, high tide is higher than normal, and the low tide, what do you think? Low tide will also be higher than average, will be as compared to any other condition, the same height, or will the low tide's height will also be impacted? What do you think? It will be lower, because all that water will go in order to support the high tide conditions. So here, lower than average. Than average. So this is the condition which we refer to as the condition of the spring tides. Okay. Now, here, when we talk about the position of syzygy, that is when we experience the high tides or the spring tides, where the high tides are higher than normal, low tides are lower than average. Now, what is the total time that moon takes to have a motion and a complete revolution around the planet Earth? Very good. It is around 28 days, right? 28 days is when it will complete one rotation, one complete revolution. So, from the earlier position which was present here, it will take the moon around 7 days, isn't it, to reach the first quarter position, right? Then again, it will take the moon around 7 more days to reach this other position which we refer to as opposition, right? So it will take it 7 days to cover this journey, further 7 days to cover another journey here, to be present here in the position of opposition. It will take it another 7 days to reach here. It will take another 7 days to come here. Yes, Prashansa, correct. So it will take around 7 days. So after 7 days, when you have experienced spring tide, moon will be positioned in the first quarter position. Now here you will observe that the lunar tide and the solar tide, they cancel out each other. But which will be the more dominant force? Always the lunar tide. So these conditions, where you have the position of the moon which is perpendicular to the plane of the earth and the sun, that position is referred to as quadrature. quadrature. That is when the moon is basically perpendicular to the plane of the earth and the sun here. Now, in these cases, what you experience is referred to as neap tides. Okay, that is what you experience. So, these neap tides basically, in this case, what do you think will be the condition of the high tide? Because here you will observe that the lunar tide and the solar tide will tend to cancel out each other, right? So, what do you think will be the height of the high tide? High tide will be lower than average. And the condition of low tide, in the condition of low tide, as compared to the spring tides, there the low tide, in that condition, the water level will be slightly higher. Okay, so that is where low tides will be slightly higher than the condition of spring tide. Okay, so here, based upon the classification, so when the sun, the moon, and the earth are in a straight linear position, the height of the tides will be much higher. They occur twice a month, once on a full moon period and another during the new moon period. During the new moon period, again, this is something where the moon is not visible because the sunlight is blocked. So that is where you have the new moon period. And in both these conditions of opposition and conjunction, you will experience the spring tides. So when the sun, the moon, and the earth are in the same position, the position is referred to as Suzuki. The Suzuki can be of two types. That is where conjunction and opposition. But in quadrature also, sun, moon, and earth are in straight line. Where is it that in quadrature the sun, the moon, earth, the sun, the earth, and the moon, are they in a straight line here? Garvit, how can you say that this is a straight line? Can you see the position here? Is this in a straight line? Are you talking about the line between the moon and the sun and the moon and the earth? So any 2 points can be joined by a straight line. So that does not hold any kind of an angle. Okay, so conjunction is when the moon and the sun are on the same side. Opposition is when the moon and the sun are on the opposite side. That is the condition of conjunction and opposition in these cases. High tide, because both the solar and lunar tides will add on. So let me write it down. So here, both the solar and lunar tides add on to each other. Okay, so that is why you will get a condition where the high tide is higher than average and the low tide is basically add on to each other. So in this case, high tide is higher than average. And because the high tide is much higher than average, you will require the water from the other regions to support that high tide. So in other places, you will observe low tide is lower than average. Okay, so that is basically the condition of spring tides. After every 7 days from a spring tide, you have a condition of neap tide because it takes the moon a span of 7 days to cover that journey. So that 7 day interval between the spring tides and the neap tides does exist. Now, in this case, the sun and the moon are at right angles to each other, and the forces of the sun and the moon tend to counteract each other. Now, the moon's attraction, more than twice as strong as the sun, is diminished by the counteracting force of the sun's gravitational pull. So, both the lunar and the solar tide will cancel out each other. Both lunar and solar tides cancel out each other. Okay, they will tend to cancel out each other. Now, the characteristics of tides. So, wherever you have the continental shelf area, there, because of the topography of the coastline, the bulge in the tide oftentimes gets exaggerated. Okay, wherever you will find that the continental shelves are very, very wide, that is where it tends to get exaggerated. So, for example, take the case of Chandipur in Odisha. So let's suppose this is a wide continental shelf. So let me tell you what do we mean by this in different areas. So let's consider an area where the coastline has got a very gentle gradient, very, very gentle gradient. Okay. So here, let's suppose you will consider, if you consider the position of the surface water here, let's suppose you have the normal water level at this position. Now, during the condition of the low tide, the water level will go down. So, the water level, let's suppose during the condition of a low tide comes up till here. During the condition of a high tide, water level will go up. Let's suppose the water level comes up till this particular portion, or if that is too exaggerated, let's suppose that the water level comes up till here. So, here, where is it heading to? So here you will observe, in order to come to that level, the water quite significantly will come up till this particular portion. This is what is referred to as the high tide line, right? The position up till which the high tide level comes into play. So this is what is referred to as the high tide line. This is what is referred to as the low tide line. So, and this particular distance in between, this particular distance that you have in between, this is what is also referred to as the intertidal zone. That is what is also referred to as the intertidal zone. So here the intertidal zone overall you will see is significantly expanded in the region of Chandipur coastline in Odisha. Now there you will have a unique phenomena where during the high tide the water comes in, and because the surface is having such a shallow gradient, it is having such a gentle gradient that during the condition of the low tide, the water level will recede significantly by few kilometers. If you ever happen to visit Chandipur, and a very beautiful place, you should. So basically there you will find that few of the shop owners which are there, now they will start packing up their things when the condition of the high tide comes. Otherwise you will find people sitting out and chilling out in the sand, and then again when the high tide comes, everything is taken back and the water comes in. So that is a very unique phenomena which is observed due to the gradient of the land. On the other hand, let's suppose if you have, yes, Manish, you would have also observed in the normal coastal areas, if you have ever been there in the beach shacks, etc., you would have definitely observed that. So let's suppose here, if you consider a coastline like this, and here you have the normal water level to this portion. Now, during the high tide, water will come here. During the low tide, water will come here. Intertidal zone is almost absent here. Why? Because the continental shelf is very narrow. So when the continental shelf is very wide and it is having a shallow gradient, gentle gradient, then that tidal bulge will be exaggerated. The shape of the coastline also ends up impacting the influence or the intensity of the tides quite significantly. Right? Many of the times you will find that the coastline has got a kind of a channelization or a kind of an enclosed shape. So, in those areas, as the water level rises up, all the water from the surrounding region will be channelized there, right? Will be rushing towards there. And again, during the condition of the low tide, everything will exit. So, there you will find a greater difference in terms of the tidal height. For this, try to locate a place today in map. Bay of Fundy, North America. Right? Bay of Fundy in North America. Now, this is where you will have the one of the maximum tidal bulges that you will come across, that you will observe. Okay, do locate this position on the map. So it is here. Basu, basically, this refers to the fact that the shape of the coastline, if let's suppose, if I give you a kind of a top view, let's suppose I give you a top view here. So if the shape of the coastline is like this, now there will be rise and fall in water level here also. But if let's suppose the shape of the coastline is somewhat like this, right? So when you have the rise, so water will tend to rush in, and that rise will appear to be very exaggerated. Again, when there is a fall in the water level during the low tides, all that water will exit because of the fluid flow, because of the shape, the funnel shape that is created. There will be greater flow. So that is where you will have in these few of the narrow bays and gulfs, you will find a significant greater distortion in terms of tidal height. Okay. Ramya, why in Bay of Fundy? Because of the shape. Locate Bay of Fundy, you will understand, and also there is some role to play with the location of it. Then, when the tide is channeled in between the islands or into bays and estuaries, they are referred to as tidal currents. It is these tidal currents that I was talking about, which exaggerates the height and basically induces a greater fall. So, what do we mean by these tidal currents? Let us talk about it. Okay, so here, let's suppose tidal currents. So let's suppose I will give you both the top view and the side view as well. So the top view of a coastline, let's suppose, is like this. Okay, here you have sea, here also you have sea, and this is your portion of land. And then let's suppose we consider this particular portion. And from the side view, if you take a look at it here, the side view appears, let's suppose, like this. Here is where you have the sea. Okay. Now, and here also you have some water. Now, when there is a rise, whenever there is a rise in water level during high tide, so all that water will rush in. Why? Because this will rise up, there will be a height gradient, so all of that will rush in. So this will have an inward movement. That is the tidal current. So all the water will rush in, and in this, water level will rise up. But then again, when the conditions of low tide comes, let's suppose where the water level falls ever so slightly. So in that condition, the new water level will be where? The new level of the water will be slightly lower than earlier comparison. So here, the new level of water, let's suppose due to low tide, is here. So now you have an opposite height gradient. So what do you observe here? All that water then drains out into this particular portion. It continues to drain out. And there the water level will be further reduced. So in larger bays and in larger gulf like areas, this tidal current is utilized quite significantly by the fishermen. And fishermen, you will observe, they will always utilize the opportunity of a high tide, because that is where it is easier to take the boat from the coastline without hitting the ground. And that is why you will always observe that the fishermen, they will never end up using the low tide. They will always end up using high tide early in the morning, around the conditions of, or even late at night, they will venture out into the sea utilizing the conditions of the high tide. Okay, this can also be used for electricity generation. Yes, perfect. So that is basically the aspect of the tides. Now, after this, we come to the portion which is relevant for both your prelims as well as the mains examination, and that is the ocean currents. Now, oceans, on the face of it, appears to be absolutely calm, plain, and featureless, isn't it? They appear to be very calm, plain, and featureless. But here also, you have a kind of a channelized movement of water. When we say channelized movement of water, what do we mean by that? By that, we basically mean that you have a kind of a flow of water in a definite direction, right? It is like a river flow and it is continuous. So, in a definite direction, water keeps on moving. Now, these ocean currents, these were basically discovered and known by the sailors in the 1400s itself. In the 15th century itself, the sailors and the merchants would be aware that these are the currents which are generated, and they would actually navigate their ships accordingly in order to save time and energy. So they keep on moving millions of gallons of water in a definite direction on a daily basis. Now, these currents also, just like in the case of thermohaline circulation, we observed that the benefit of the thermohaline circulation is the case of distribution of heat, as well as it is useful in terms of the distribution of nutrients from one region of the planet to the other. So here also the ocean current, they play the similar role. So let us understand what they are. What are the forces which lead to the formation of ocean current? So first of all, they are like river flow in the oceans, where you will observe regular volume of water in a definite path and direction. Okay, regular volume of water keeps on flowing in a definite path and direction, and they are influenced by two types of forces: and primary force that initiates the movement, secondary force that influences the direction. So here, definite path and direction is the key phrase. It is not going to be the case other than the northern portion of Indian Ocean, and which is an aberration, which is an exception. In general, you will not come across a situation where if a movement is like this, then suddenly the movement will change like this. No, that doesn't happen. The definite direction is always pertinent. It is always a regular aspect and a regular fixture. So, what are the forces which induces the ocean current? What are the forces which will induce a motion? So, first of all, you have heating by solar energy. Heating caused due to solar energy. So when the sun heats up the planet, the lower latitude will always get greater amount of heat. Yesterday also we had seen that the lower latitude overall they receive heat surplus. Now due to that greater amount of heat, you will experience a kind of a slight expansion of water. Any state of matter, any kind of matter, when it is heated up, it tends to expand ever so slightly. So here also, when the water gets heated up, it will expand ever so slightly, isn't it? So here you will observe that heating by solar energy causes the water to expand. It results in about 8 centimeter higher level at the region of equator compared to the middle latitudes. And this small gradient of water, that is difference in height, it can cause the water to flow. It can induce a motion of flow. Okay, so that is the impact. So here, that creates, heating creates a height gradient. Height gradient. right? Then, if there is a height gradient, that in itself can induce a motion, but the directionality is provided by the winds. So you have some swollen portion of water at the region around equator. And remember, yesterday we had indicated the temperature distribution, where we had seen that how the trade winds are influential in causing the movement of water. If you recall that particular chart, and if you recall that particular figure, I'll take you back to that. So here, so if you observe here, we had taken a look at this image yesterday as well. So we had taken a look that around the region of equator in the Atlantic and the Pacific, you will have the condition where there's a general movement which is observed, isn't it? You have a kind of a general movement which is observed here. General movement which is observed here. Right. So observe here the water flow. Water in a way has a flow somewhat like this, here also. So there is a bulge, but then that directionality is to be provided by the movement of the winds. So the winds provide the direction of movement, provide the direction of movement. Okay. Many of the times these winds induce the movement itself. Okay. So many of the times they can induce the movement as well. Induce movement in water. Right? So that induces the movement, heating, and then the wind. Then the movement is also impacted further by other forces. For example, the Coriolis force. The Coriolis force that we have seen will impact the wind movement and the direction of the wind. Those Coriolis forces will also be impacting the movement of the ocean in a larger area. So here also, generally you will find that water which is moving in the northern hemisphere, they will be bending in the rightward direction. Water which is moving in the southern hemisphere, they will perpetually be bending in the leftward direction. That is a common feature that you will find. So let's suppose this is the region of equator here. So if the water starts moving like this, then it will start bending in the rightward direction. It will further bend in the rightward direction, carried by the westerlies, then further bend in the rightward direction. And you have a continuous bending. Similarly, in the southern hemisphere, water will bend like this, leftward direction in the case of the southern hemisphere. So this circulation that is induced after the movement has been initiated, so the shape of the motion, the direction of the motion is oftentimes defined by the Coriolis force. So moves water to the right in northern hemisphere and moves water to the left in the case of the southern hemisphere as well. Okay. So that is where in the northern hemisphere, generally you will find that there is a kind of a circular or a kind of a clockwise motion in the water, and in the case of the southern hemisphere, anti-clockwise. There is one exception, however, and that is the northern Indian Ocean. It is in the northern Indian Ocean where the wind factor is so dominant that the ocean currents in the northern Indian Ocean, they reverse their direction in between the various seasons. And can you think about the logic behind that? The logic is very simple, guys. We know that the northern Indian Ocean, unlike the case of the Atlantic or the Pacific, the northern portion of Indian Ocean is actually closed by the landmass, isn't it? There you have the closing by the landmass. So there you will also come across a situation where the wind direction reverses. The wind completely reverts its direction, isn't it? So there in the northern Indian Ocean. We'll come to the portion of Indian Ocean. I will further elaborate upon it. I will repeat it again. Don't worry about it. As of now, just try to think about it. That in the case of the northern Indian Ocean, or let me take you to the image itself. Let's do one thing. So as of now, just observe the northern portion of Indian Ocean. Ignore the rest of the image here. Now, in the northern portion of Indian Ocean, during the month of the advancing monsoon, what is the direction of the wind? The direction of the wind is southwest to northeast, isn't it? So observe the direction of the flow of water. And then during the northeast monsoon, what is the direction of the wind movement? Northeast to southwest, isn't it? So observe that the entire circulation gets reverted. So it is the only exception of all the various oceans. This is the only exception which prevails, where the oceanic current reverses its direction in between the various seasons because of two factors. First, it is so very closed by the land masses, because if you take a look at the Pacific is open in the north, open in the south. If you take a look at Atlantic, open in the north, open in the south. But if you take a look at the Indian Ocean, it is closed in the north. So here the impact of the wind will be much more exaggerated. And when the impact of the wind is much more exaggerated, as the winds will revert their direction, the ocean currents will also revert their direction. Is this understood? The impact of wind, is that understood, or is there any doubt prevalent? Chandrasekhar, is it understood now? What is not understood? Which portion? If anything is not understood, point out the portion which is not understood. Why this clockwise and anti-clockwise? Okay. Solar tides, Mayank, are because of the gravitational pull of the sun. So here, think about it. Let me erase this all and think about. Okay, in Indian Ocean, because Chandrasekhar, I hope you are aware that in Indian Ocean we have northern Indian Ocean, we have the reversal of winds. Do you, or are you comfortable with that fact? Pula, you as well. Are you comfortable with that fact that in the northern Indian Ocean you have a reversal of winds between the various different seasons? No, not because of El Nino, because of the monsoon. Have you read the portion of monsoons, or is that completely skipped? Have you understood the portion of monsoon where we had seen the portion that the advancing monsoon, you have the wind direction from southwest to northeast, right? So the wind direction reverses. So the wind direction, as it is reversing, it will induce a motion in the ocean as well, because the winds will be able to carry the wind. And the northern Indian Ocean is closely bounded by the landmass. So hence the impact of the wind will be much more exaggerated. Okay, right? Now, about the clockwise and anti-clockwise. So let me erase this and let me explain this again in this particular portion. About Indian Ocean, it is an aberration. Don't worry about it. We'll come to it. Once you understand the Atlantic, the Pacific, Indian Ocean is very easy to understand. Okay. So here, if you have a movement which is initiated like this, let's suppose. Furthermore, the movement will be bending to the right due to the Coriolis force in the northern hemisphere. It will again bend to the right. It will again bend to the right, again bend to the right. And what kind of circulation do you have? You have a kind of a clockwise circulation, right? In this case, here, it will bend to the left, bend to the left, bend to the left. What kind of circulation do you have? You have an anti-clockwise circulation. Don't confuse it with the cyclonic, anticyclonic movements. There, the circulation is different. Here, the circulation is completely different. Okay, right? Now, then another influence on the direction and the shape of the ocean currents is basically laid by the direction of or the shape of the coastline. The shape of the coastline oftentimes induces a different movement. So here, for example, let's suppose Basically, let's suppose you have this. Now, as the water hits this region, water will automatically be deviated northwards here. It will be deviated to the northern direction. It will follow the coastline. Now, here, because the around the region of the Yucatan Peninsula, this is the Yucatan Peninsula, you will observe that there is the Gulf of Mexico. So, water will get entrapped here. Here, you have the Caribbean islands. So, there the water will get split. Again, as the water comes out of here, both of these will combine. So all this variation in the water movement is induced because of what? Because purely of the shape of the coastline, isn't it? So that shape of the coastline will also end up influencing this directionality along with the Coriolis force. So that is where you will oftentimes find that the direction of the ocean currents are influenced by these minor factors as well. You have another minor factor, that is the bottom relief. Why phytoplanktons are created due to warm and cold current? Their population increases because of increase in the amount of dissolved oxygen. So, bottom relief features. So, what do we understand by the bottom relief features? For example, mid-oceanic ridges, seamounts, in example. Now, in many of the cases, the water is so very deep, and these bottom relief features, they don't come close to the surface, so they don't impact it. But in certain cases, let's suppose this is the water level. Here you have the ocean bottom. Now let's suppose the ocean currents are present in the top portion, and here you have the presence of a kind of a ridge. So the ocean current will also get impacted by this, isn't it? So, for example, in certain places, you have the presence of these mid oceanic ridges very close to the surface, and that will end up impacting or end up bifurcating and trifurcating the movement of the ocean currents. For example, let's suppose, if you consider this, let's suppose here we do know that you have the mid Atlantic ridge going all across this particular area, right? Mid Atlantic ridge we are all aware of. Now that mid Atlantic ridge is not very continuous. In certain areas it is much higher, in certain areas it is much lower. So here a part of the mid Atlantic ridge which exists. So mid-Atlantic ridges also have various names. If you have taken a look at the atlas, you would have found Socotra Ridge, Carlsberg Ridge, etc. So here, mid-oceanic ridge rather. So here in the case of mid-Atlantic ridge, you have a particular portion of the ridge is situated in northern Atlantic. That is what is referred to as the Wyville-Thomson Ridge. You don't need to remember the name. This is just for your information. It is a part of the mid-Atlantic ridge. Part of mid-Atlantic ridge. And what it does, here you have an ocean current, that is the North Atlantic drift. And that North Atlantic drift, when it hits that ridge, the water starts getting divided. So it divides the North Atlantic drift, the ocean current divides the North Atlantic ridge or drift, which is an ocean current. Now, that North Atlantic drift, furthermore, their movement will be exaggerated by the distinct shape of the coastline. So, observe the shape of the coastline here in the portion of northern Europe. So, here you have North Sea, here you have the region between Iceland, Greenland. So, water starts entering into various areas. Here you have the Norwegian current, then some water will come here, Some of the water will even, in fact, enter into the portion of Mediterranean from the Strait of Gibraltar. So these movements are induced particularly by the shape of the coastline themselves. But eventually, the majority and the major chunk of the water will be directed southwards, induced by the shape and also induced by the Coriolis force and the bending of the Coriolis force. So that is how the shape of the coastline will also end up impacting the motion. Okay. So now let us take a look at few of the characteristics of these ocean currents. Then we will try to understand each of these ocean currents in terms of where they are present, their names. That will be more than sufficient for your general studies. So currents are going to be strongest near the surface, and their impact reduces as you move further down. Okay. So at the surface, why? Because let's suppose you consider the surface of sea water. Now, here, if you have the wind movement, let's suppose, if you have a very strong wind movement that you have encountered. Now, this wind movement will be attracting or dragging this water. Strong in terms of speed, speed of motion. Okay. So, this wind movement will try to drag the surface water to the maximum. That surface water will try to drag the subsurface, isn't it? That will try to drag the portion below it. The wind movement will have no impact of the movement of water here at this depth. That water will be moving only because the water above it is moving. So the impact will keep on reducing as you go to the depth. So at a depth of around 300, 400 meters, you will find that this movement actually diminishes and stops. So that is why the currents are strongest near the surface in terms of their velocity, in terms of their directionality of movement, and may attain a speed over 5 knots. Okay, how many of you are aware or not aware, or how many of us are aware about what is meant by knots? Knots is a speed that, or is a kind of a unit that you will always also hear the sailors and also the pilots. They also use the term knots quite significantly, right? So, what is knots? Very good. Knots is basically a unit of speed. So, one knot represents close to around 1.8 kilometer per hour. Don't confuse it with nautical mile. Nautical mile is a unit of distance. Knot is a unit of speed. So knot is a unit of speed. Okay. Generally used for navigation purposes for centuries altogether. And here you have a kind of an anecdote that why this knot was used, because it used to be uh, significantly in prominence in order to measure the depth, in order to measure, let's suppose, the distance in water. So in the case of distance in water, you would use very long ropes with knots in between in order to connect those ropes together. So that knot would represent, nautical mile would represent a particular distance. And that is how the knots came in. Okay. So here knots represent speed. So at depth, the speed reduces to close to around 0.5 knots. Then you have the classification of current based upon where it is to be found. All the ocean currents that we are going to study as of now, they will be the surface currents, but they represent only 10% of movement in terms of the water, right? Only up till a depth of around 400 to 500 meters from the surface will you experience the impact of these surface currents, because beyond that depth, all these impact or all these influences of heating by the sun, of the wind movement, that is not going to be felt at a greater depth of the ocean. So all the ocean currents that we are going to study, they are basically categorized into the portion of the surface current. But then you have the deep water current as well. So deep water currents, they move around the ocean basins due to variation in density and gravity. That is, the thermohaline circulation that we studied. Remember, where you had the subsurface current and the deep water current. So these deep water currents, they, I will write it down and it is written in the PPT further ahead as well, helps in heat circulation as well, but much more importantly for the biodiversity, helps in nutrient circulation. Okay, it also helps in significant amount of nutrient circulation. Now, then you have the classification of current based upon the temperature. You have the cold current and the warm current. Now, just like in the case of wind movement, you had cold advection and warm advection. What was cold advection, if you can recall? When you have the cold winds which were blowing in a region, right? When you have warm winds blowing in a region, warm advection. So just like that, here also you have the cold ocean current and the warm ocean current. Okay, there is no absolute temperature that if the water temperature is lower than this, then it will be cold current. If the water temperature is higher than this, then it will be warm current. No, this is purely based upon the comparison from the surrounding water temperature. If the ocean temperature or if the ocean current temperature is higher than the surrounding water temperature, it is a warm current. If the ocean current temperature is lower than the surrounding water, it will be a cold current. So this is dependent on the surrounding water temperature. So if the ocean current is warmer than the surrounding water, it will be warm current. It will be referred to as a warm current. Okay. If current is colder than surrounding water, it is a kind of a cold current. Okay, that is what is a warm and a cold current. So one oceanic current can be warm in a particular region, and the same oceanic current can be considered to be cold in another region. How? So let us understand that. So let's suppose I bring to you the example in a certain case. Here, let's suppose we have the equatorial region in this area. Now here, let's suppose you have the ocean current moving in this direction. The ocean current's temperature is, let's say, 15 degrees Celsius. Okay. Now this ocean current, after hitting the landmass, this divides. It divides. One portion goes to the higher latitude, another portion goes to the lower latitude. Okay. Now in the lower latitude, this temperature of the ocean current is 15 degrees Celsius. Right? In the higher latitude, the temperature is, let's suppose, still maintained at 15 degrees Celsius. Now, in the lower latitude, what will be the surrounding temperature? in general, in the tropics, we have talked about yesterday that the surrounding water temperature is around 24 degrees Celsius, right? In the higher latitude, let's suppose the water temperature is 10 degrees Celsius in the higher latitude. So the same ocean current will be rendered as the cold current in the lower latitude, and this will be rendered as warm current. Right. So the same current can be cold, can also induce a kind of a warm current. It depends upon the surrounding water temperature. Generally, you will find that the ocean current which comes from lower to higher latitude will bring warmer waters to the higher latitude. So they are generally warm currents are the ones which move water from lower to higher latitude. And in the case of the water movement from higher to lower latitude, generally you will find it is the work of the cold current. So here you will observe that when we talk about the cold currents, how higher temperature becomes colder. Observe here, my dear friend. Observe here. The current temperature is 15 degrees Celsius. Surrounding water temperature is 10 degrees Celsius. So in this, as compared to the surrounding water temperature, it will be warm. Here, the ocean current temperature is 15 degrees Celsius and the surrounding water temperature is 24 degrees Celsius. So in comparison to the 24 degrees Celsius surrounding water, will this current be considered cold or warm? Subramania, let me know. Will this be considered cold or warm? Cold? Is that understood? So, the temperature of the ocean current, when compared from the surrounding, it can be referred to as cold or warm. If the surrounding water temperature is much hotter, then the ocean current is cold. If the surrounding water temperature is much colder, it will be warm current. Okay, as simple a logic as that. So, here, not clear why the direction of current is assumed. In the sense, first of all, here we had considered a random one, but then which is the portion that are you confused that why this will bend here to the left? Is that what the confusion is? That is because it hits the coastline. So that is where when it hits the coastline, it will divert. It will basically diverge after hitting the coastline. It is the shape of the coastline which will influence this. So when we talk about the portion of the it applies at the surface current we are talking about. So cold currents, they bring colder waters into the warm water areas. Generally, you will observe that these cold currents, they are the movement of water from higher latitude to lower latitude, because water temperature in higher latitude will always be lower, right? So generally brings water from higher to lower latitudes. Okay. Now, they are usually found across the west coast of the continents in the low and the middle latitudes. In the region of the low and middle latitudes, generally found across the west coast, the cold currents. Why? Because there you will observe in the low and middle latitude, here, let's suppose if I consider this particular image again. So here, let's suppose I consider this landmass. Okay, like this, let's suppose. Now, the wind movement here will be the trade winds. Now, these trade winds will lead to upwelling or downwelling in the coastline here across the western coast. They will cause upwelling or downwelling as these trade winds move. They will cause upwelling. Upwelling will reduce the surface water temperature. Upwelling always ends up reducing the surface water temperature. So the ocean current which is induced thereafter will be colder water. So generally cold currents you will find on the west coast of the continent. Whereas what happens on the east coast then? So across the east coast, if you have the wind movement somewhat like this, so these are your onshore winds. Onshore winds lead to the condition of downwelling. So because of the downwelling in this area, the water temperature will increase, right? So the ocean current induced across the east coast will be warmer in nature. Okay, so that is the characteristic. It all follows the simple logic of temperature, movement of wind. That is it. If the portion of temperature, wind movement, etc. is clear, everything else will be clear accordingly. So then, when we talk about the warm currents, they end up moving warm water into the cold water regions. So generally, water movement from lower latitude to higher latitude. Okay, because lower latitudes water will always be having much warmer temperature, much higher temperature. So when they are brought to the higher latitude which is colder, it will be considered as a warm current. They are usually observed across the east coast of the continents in the low and middle latitude, only in the low and mid latitude, not in the higher latitude, only in the low and mid. Okay, because of the influence of the trade winds here as well. Okay, Charan, what is your question? Please put it forward. I will generally take up questions at the end, but then fair enough, if something is bothering you quite significantly, ask the question. So here, let's consider the ocean currents one by one, and let's start with the Atlantic. Now here, please understand, in the additional reading materials, you will find all the various different currents explained and written. So don't worry about it whether or don't start taking copious notes as of now. As of now, I just want you to observe this phenomena. This phenomena follows an absolute simple logic of wind movement, shape of coastline, as well as the Coriolis force. That is it. It is these three principles which will drive the ocean current. I will write it down as well. So basically, here, wind movement, Coriolis force, and also the portion of shape of coastline. When you have to write the answer in the examination, in the mains examination in 2022 also, UPSC had asked about the question. When you have to write the answer, start with the prime role. Most important role is played by the solar insolation and heating by the solar insolation. Okay, then talk about the wind movement, then talk about the Coriolis force, then talk about the shape of the coastline, then talk about the bottom relief features. But solar insolation is very important when you are writing the answer. This I am telling you that in order to understand, just keep a track of these three factors. You will be able to understand. Don't take copious notes here. Pay attention, observe the logic. The written text about each of these currents you will find in the additional reading materials. Okay. Now, here, when we take a look at it, yes, Laksh, that can be done. Absolutely. So understand one by one what happens here in this case, one by one. So here, when we talk about the equatorial area, let me represent the equatorial area somewhat to represent or to indicate what is actually happening. So at the equatorial area, we have seen there is a greater amount of solar insolation and that greater amount of solar insolation will induce a greater amount of heating in the process, right? Let's suppose we represent somewhat like this. Okay, I'm just representing the region of equator. So, around the region of equator, there will be greater heating, water will get bulged up. But when the water gets bulged up, then the directionality is provided by the movement of the trade winds here. You have the movement of the trade winds, right? In all these areas, you have the movement of the trade wind. So, what will the trade wind do? The trade wind will start pushing the water towards the west. Simple. The trade wind will start pushing the water to the west. Now, here, the water is driven to the west. Around the region of equator in itself, not much of a Coriolis force, so almost a straight kind of motion. Then, the water will hit the coastline. Now, when the water hits the coastline, few things happen as a result of that. As the water hits the coastline here, one portion induced by the shape of the coastline will be driven northwards. Now the Coriolis force will start acting. Here, due to the shape of the coastline, water will be driven southwards. Now the Coriolis force will start acting. But also, some amount of water will keep on getting accumulated here in between. Some amount of water will keep on getting accumulated here. Now the planet is continuously rotating from west to east, right? Continuously it is rotating from west to east. So that induces a kind of an inertia. And that accumulated water, due to the rotation of the planet, due to the accumulation, this water starts flowing back. There is a flow back. Very slow, very light, but a flow back nonetheless. Right? So the northern portion, that is what is regarded as north equatorial current. Equatorial current. This is regarded as the south equatorial current. Equatorial current. And then the portion which tends to flow back here, that is regarded as the counter equatorial current. This is your counter equatorial current. So that is what happens at the region of equator. So that is how the motion is induced. A movement is induced. Once that movement is induced, after that you will observe continuously water tends to move. And water basically, you have the, due to the trade winds, the water will be dragged towards the westward direction. Some water will be deviated to the north due to the shape of the coastline. Some water will be deviated to the south because of the shape of the coastline. And then some amount of accumulated water in the region of the east coast of South America here, some amount of accumulated water will initiate a flow back, what we refer to as the counter equatorial current overall. Okay. And this counter equatorial current is influenced by the rotation of the planet from west to east. And that rotation induces that kind of a applied motion. It will also induce a kind of a wind direction here, also very light wind direction, but don't get into that. So that induces a kind of a counter equatorial current. Now, here, north equatorial current, as it moves, then it will encounter the Caribbean and the Antilles Island, right? You have Bermuda, you have Trinidad, Tobago, Jamaica, all these islands of the Caribbean are situated there. Now, that will divide the water into two portions. Divide the current into two different portions. What is also referred to as the Antilles current, right? But that case, what is or that is primarily because of the islands lying in the pathway of the water movement. Now here, water enters into the region of Gulf of Mexico through the Yucatan Peninsula and the narrow channel. Water enters into the region of Gulf of Mexico. Now, after that, it comes out from the region around the Florida coastline. Florida is the southeastern state in United States. It comes out from the region of the Florida coastline. It comes here. Now, here, as the water emerges back into the Atlantic Ocean, it will end up meeting with the ocean current which was coming to the north of these Caribbean islands. So now, what will be the intensity of the ocean current? Will the intensity be more? Will the intensity be less? What do you think? It will be much more. It will be very high. So this is where you get one of the strongest warm ocean currents of the globe, and that is referred to as the Gulf Stream. So that Gulf Stream is generated. It is one of the strongest warm ocean currents which are out there. Now, meanwhile, aided by the polar easterlies. What is the direction of movement of the polar easterlies? It is in this direction, right? So, aided by the polar easterlies, there will be some movement of the ocean water from the higher latitudes as well. But then the shape of the coastline will actually influence their direction of movement. So here in the northern portion of North America, you have the Labrador Sea. So from the region of Labrador Sea, you have the Labrador current, which is a cold current which comes. Now this cold and the warm ocean current, they will meet here around the region of Newfoundland. That is where they will encounter, that is where they will meet. Once they meet, that creates basically the ideal fishing grounds. The world's most ideal fishing grounds are created when you have the meeting of the cold and the warm ocean current. Because once they meet, the level of oxygen in the water goes up. It creates a condition ideal for reproduction of the fishes as well, and the fish population goes significantly higher. So this is where you have the world's most ideal fishing grounds created. Now then, this Gulf Stream, by the way, will continue to stay warmer, right? It will retain its characteristic because Labrador current is not that intensive that it will warm up the or cool down the Gulf Stream. So Gulf Stream retains its character. Now here, the Gulf Stream is then directed in the eastward direction by a permanent wind system. Which permanent wind setup here will help the Gulf Stream move to the east from west to east? Which permanent wind setup? Very good. You have the westerlies. So you have these westerlies which will carry these currents from west to east. And this is the portion where, for the initial stages, they are referred to as west wind drift, then they are referred to as the North Atlantic drift. Now, this North Atlantic drift is basically the warmer water which has been brought from the lower latitude. So it will still be warmer. This North Atlantic drift then is divided into various parts, various subcomponents based upon the shape of the coastline. One portion enters the region around Norway and Norwegian coastline, which is referred to as the Norwegian current. This Norwegian current is also warmer. So it keeps the coastline across Norway, many of the areas across the coastline of Norway, ice free throughout the year or most parts of the year. Because of what? Because of the warm ocean current. So that enables fishing activities, that enables trading activities, that enables economic activities in general. So that is the role of the warm current here. But some of that warm current will enter into the region here, North Sea. Some portion will enter into the region around Iceland. Some portion will move around the region of Bay of Biscay here, between the region of Portugal, Spain, and France. Some portion will also enter into the Mediterranean Sea. So you have the classification of the North Atlantic drift into Irminger current, Rennell current, Norwegian current. All these are the various classifications. You don't need to go into the depth of that, right? So here, this majorly aided by the shape here and the Coriolis force, they will start deflecting to the right because we are in the northern hemisphere. So they deflect to the right here. Now, the ocean current this time is coming from a higher latitude to a lower latitude. So let's suppose the temperature of water here, let's suppose it is 17 degrees Celsius. Let's suppose, just an assumption. But at the lower latitude, the temperature of water at any point will be close to around 24 to 25 degrees Celsius. So that is where the ocean current, which will bring water to the lower latitude, that will be considered to be a cold current because it moves around the region of the Canary Islands. Hence, it is the cold Canary current. Okay, it feeds back into the north equatorial current, and you have the entire circulation which is achieved. Okay, I will repeat this entire process again. So refer to this entire process again and try to understand this. Now, here, when we talk about this particular movement of the ocean current, it is initiated or induced at the region around equator. Okay, what happens at the region around equator is basically, at the region around equator, you have heating by the solar insolation, due to which the water level increases. Then by the movement of the trade winds are generally moving from east to west direction. So due to the movement of the trade winds, that swollen water is provided direction to move in the westward area. It moves westward. To the north of the equator, it is referred to as the north equatorial current. To the south of equator, referred to as the south equatorial current. Now here, you will observe that after hitting the coastline, it diverges into northward and southward direction. Some water will accumulate here, and that water will have a flow back, what is referred to as the counter equatorial current, and that flow back is initiated because of the rotation of planet earth from west to east direction. Now as it gets diverted, this north equatorial current, this will encounter the Caribbean islands in between. Now once the Caribbean islands, they lie in between, the current will diverge into two. One portion will go to the north of it, other portion will go from the south of it. Okay, so you have one portion going from north, one portion going from south. The portion which goes from the south will enter into the region of the Gulf of Mexico. From the region around Florida, they will have an exit, they will move out, and here they will be joined by the ocean current coming from the north of the Caribbean islands, right? And when they join, they will be very intensively powerful. Lot of water will be moving, and it will be warmer as well because it is coming from the equatorial and the tropical region. So that will induce one of the strongest warm water currents across the planet, that is the Gulf Stream. Meanwhile, due to the polar easterlies, due to the polar easterlies, you have the movement induced in the water in the higher latitude as well. And that movement in the water, aided by the shape of the coastline, generates some cold currents in the higher latitudes. Now, these higher latitude current, you have one of them coming from the region of the Labrador Sea. That Labrador current will mix with the portion of the Gulf Stream. And when it meets with the portion of the Gulf Stream, here it will not only end up creating a kind of a sea fog. Why? Because here you have warm water meeting with cold water. So, in a way, warm air meeting with cold air. So, you have a kind of an advection fog process where the warm water, as a warm air, as it meets with the cold air, there will be some condensation, a lot of sea fog, a nightmare for navigation. But in the region of water, this will improve the level of dissolved oxygen, improve the amount of fishes. These are the best fishing grounds across the world. Wherever you have cold and warm ocean currents meeting, they are the best fishing grounds across the world. Nonetheless, this Gulf Stream is then carried eastward with the help of the westerlies. And then it is referred to as the west wind drift or also the North Atlantic drift because we are in the northern portion of the Atlantic. aided by the bottom relief and the shape of the coastline. That North Atlantic drift, it diverges into various portions. One portion goes into the region between the North Sea. One portion goes across the region of the Norwegian coastline, that is the Norwegian current. One portion goes through the region of Bay of Biscay. Then one portion even enters into the region of the Mediterranean. Now, here, eventually, the net motion will be the rightward deviation and deflection due to the Coriolis force and the shape of the coastline. And that is where you will observe now the water is being brought from higher latitude to lower latitude. So higher latitude, if the temperature of ocean current, let's suppose, is 17 degrees Celsius, at lower latitude, let's suppose the temperature of the surrounding water is 24 degrees Celsius, it will be considered to be a cold current, right? Because 17 degrees is much colder than 24. So that cold current, which will move around the region of the Canary Islands, is referred to as the Canary current. Okay? So that is how you have circulation in the northern Atlantic Ocean. Is that understood? Sargasso Sea is in the region around the portion of the Caribbean, to the north of the Caribbean. We'll come to it. Any possibility to arise the question about the process of Atlantic Ocean currents? Absolutely, yes. What can be the geographical explanation of the Bermuda Triangle? I won't go into that. Okay. And I have clarified multiple times in the classes that Bermuda Triangle and the areas around the existence of Ram Setu, all these particular mysteries, mythologies, I won't get into. It is a magnetic anomaly in the case of Bermuda Triangle, that is at max. Polar easterlies will induce a motion in the higher latitude. How does it move in opposite direction? What moves in opposite direction? Are you talking about the counter equatorial current? How does what move in the opposite direction? Last, please repeat last line. What last line, my dear friend? Which is the world's best fishing grounds? Wherever you have the cold and warm ocean currents, they meet. What type of questions can be asked from this topic? You can have an identification or a kind of a identification that which ocean current exists in which ocean current is warm or cold in the prelims MCQ type, or you can have a mains type of a question, discuss the factors which influence the ocean current and elaborate upon the formation of ocean currents in the North Atlantic. After water is brought from high to low latitude, so as water is brought from high to low latitude, it becomes a colder current because water in higher latitude is going to be colder. So that is why it becomes the cold ocean current, which then feeds back to the circulation of the north equatorial current. Counter movement of the at equator. So here, north and the south equatorial current will lead to the accumulation of water here. That accumulated water will generate a kind of a flow back that will be induced by the inertial motion of the rotation of the planet Earth. That is why. Okay? Right. Okay, is that understood? Since Gulf Stream warmer, thus frontal cyclone can be there. Yes. Very good, Laksh. Beautiful. So let's take a break now, guys. Let's take a 10 minutes break and we'll be back and we will continue with this. A confirmation about the audio, please, guys, if the audio is clear and available. Thank you. Deepak, the west wind drift is basically aided by the westerlies. That is the permanent wind system in that particular region. In those latitudes, you have the westerlies, and westerlies also move from west to east. So that is what will aid the motion. Okay. Now, after this, if we take a look at the southern portion of Atlantic, the process is almost similar. Here, the bending is towards the left because of the Coriolis effect. Otherwise, the process is almost quite similar here. So here, if you take a look at it, basically, the south equatorial current, that south equatorial current, when it hits the Brazilian coastline, the shape of the Brazilian coastline in itself will induce a leftward bend. And that leftward bend will form the warm Brazil current. Okay. Now, meanwhile, in the region of the Southern Ocean, you will have a consistent movement of cold water in the west to east direction. And this is aided by the westerly movement. So, this is aided. So, across the entirety of the region around Antarctica, you have the Southern Ocean. I hope we are aware about the names of the oceans across the world. How many oceans are there in the world overall? Let me have this basic question. Hmm. So, Taran, Khushi, Garvit, could you name the seven oceans that are present? Nandini, Smriti, could you name the seven oceans which are present? Can you think about the name of the seven oceans? Please let me know. Arctic, North Atlantic, South Atlantic, North Pacific, South Pacific. Then why not North Indian Ocean, South Indian Ocean? It is not there. So these are okay. So many of the things I'm assuming that you guys know. So basically, there are five oceans in the world and seven continents in the world. Okay, so five oceans and seven continents. So I'm sure you would have read this in your school level, in your sixth or seventh standard, or even before that also. In your summer projects, many of the times you would have had the task of drawing the planet Earth or drawing the globe, and then naming the oceans, naming the particular continents, which are the particular continents. So I'm sure you would have covered that. There are five oceans. I will not further elaborate upon this. The five oceans are Pacific, Atlantic, Indian, Southern Ocean, and then the Arctic Ocean. Right? Remember it by the acronym PAISA, PASA. So that is Pacific, Atlantic, Indian, Southern, and Arctic. Okay? Right? Then why do we call Sat Samundar Par? Okay. See, in the if you have these type of questions, I don't have answer for these type of questions. That why it is referred to as Sat Samundar Par, etc. So here, please understand, I can only give you the names of the various different oceans which are there. This is a question I was asked in state PSC interview. Even that time, my answer was wrong, and I argued with the chairman that there exists only four. So I have full sympathies with the chairman of the interview panel there. Basically, that poor chap would have had to argue about the name of the oceans. So here, again, I would repeat the basic oceans that are there. You have the Pacific, Atlantic, Indian. In the north, you have the Arctic. In the south, you have the Southern Ocean. Okay. Now, I hope that is understood. Overall, ocean current direction and cold ocean current direction is not the same. How? Overall ocean current direction and the cold ocean current direction is not the same? Please elaborate upon this doubt. Write the exact question that you faced. Okay. Yes, Sakshi, I think that is the case. Okay. So here, now if we come back to the portion, so that diverted my attention to such an extent, and I apologize to the rest of you for that. So basically, in the Southern Ocean, that is the ocean around the region of Antarctica, you have the Southern Ocean. It continues and exists around the region of Antarctica. So in that area, you have the prevalent flow of the westerlies. And remember, we had discussed about the westerlies that in the Southern Ocean, they are very strong as compared to the Northern Hemisphere. The Southern westerlies are much stronger because of the presence of the oceanic water body. That is why you have the shrieking 60s, roaring 40s, furious 50s, all of these. So it is these oceans or these winds which will induce a west to east direction of movement, which moves across the region of Antarctica. If you observe the southern portion of ocean here, observe the southern portion of ocean in Pacific, observe the southern portion of ocean in Indian Ocean. In all of these, you will find a continuous formation of this west wind drift. This is induced by the westerlies. Okay, induced by westerlies. No, Manish, that doesn't happen. Okay. So here, that west wind drift, which is circumpolar in a way that moves across the region of Antarctica, all around the region of Antarctica. Now here, some portion of that west wind drift will divert itself to the leftward direction owing to the Coriolis force in the region around the Falkland Islands. Falkland Islands, you would be aware if you have read about the Falkland War, which was fought between Britain and Argentina. So that Falkland War, it happened for the control of the Falkland Islands. So around the region of the Falkland Islands, you have the Falkland current, the cold Falkland current, which comes into play. Now that interacts very in a minor way with the Brazilian current. Then after that, here you will find this Brazilian current is subsumed by the cold west wind drift. This west wind drift again diverts to the leftward direction due to the Coriolis force and forms the cold Beniguela current because it is bringing water from the higher latitude to the lower latitude. So it will again form a cold ocean current. And that is what completes the entirety of the circulation. I will repeat again. So here you have the south equatorial current. After hitting the region around Cape Verde, after hitting the region around the Brazilian coastline, it will divert to the left. And that is where, induced by the Coriolis force, you have the Brazilian current. That Brazilian current very slightly so interacts with the Falkland current. It doesn't have a much greater interaction because the Brazilian current continuously will bend to the left, whereas the Falkland current also, which is a leftward bend of the west wind drift, it moves very closer to the coastline here. Now, that Brazilian current will then be subsumed by the west wind drift here. And that west wind drift, after some distance, will again divert to the left owing to the Coriolis force. And that will be the cold Beniguela current. And the entire circulation will be completed. At the equatorial region, does the rainfall increase the volume of ocean? No, not significantly, very minorly. It is the insolation which will increase the volume. Okay, understand. Chandrasekhar, but in South Antarctic polar side, as easterlies due to the Coriolis force, then how western side wind form? So easterlies, the polar easterlies that you are referring to, that will be at further higher latitude. That will be driven much closer to Antarctica. We are talking about the region higher up as compared to Antarctica. So here you will have the dominance of the westerlies. Why winds from equatorial regions to Gulf Stream become warm? Winds, are we talking about the winds, or Yashi, are you talking about the currents? The currents are warm because they carry warm water from lower latitude to higher latitude. Hence, they are warm current. Okay, right? Now, This is about the Atlantic Ocean. Then, when we talk about the Pacific Ocean, a very similar approach is observed. Okay, Megha, you have put the correct question now. Cold currents flow from polar regions, travel towards the equator. They flow in clockwise direction in the northern hemisphere. So here you would have had the statement or the framing of the question as consider the following statements about ocean currents, and then you would have these particular statements, Megha, if I'm not wrong. So cold currents generally move from polar region towards equator. That will be correct. And they flow in clockwise. The ocean currents, they flow in clockwise direction in the northern hemisphere. That will also be correct. Right? Is that understood, Megha? Or is there a doubt which prevails? Okay. Why west wind drift is not affected by Coriolis force? It is affected by Coriolis force. Observe in the case of the Atlantic Ocean, here also you have a movement. So here, and the Megha, you had a doubt about the cold currents. Observe the cold currents. The cold currents in the northern hemisphere, they will be moving from the polar region towards the equatorial region. But what is the general direction of motion of the ocean current in the northern hemisphere? It is clockwise, right? In the southern hemisphere, it is counterclockwise, right? Why then Labrador current is anti-clockwise? Labrador current is not anti-clockwise. Labrador current is induced due to the polar easterlies. That induces a motion here. And then Labrador current, you will observe, it simply sticks to the coastline. Shape of the coastline is what determines the East Greenland current, the Labrador current, the Falkland current. They are all driven by the shape of the coastline. Okay. Right? Now, then we come to the portion of the Pacific Ocean. Now, in the Pacific Ocean also, you will have a kind of a similar principle where you will observe that due to bulging of water around the region of equator, after that it is carried in the westward direction due to the movement of the trade winds. Here you will have the movement of the trade winds. Here you have the movement of the trade winds. Now, these trade winds, they will be acting both in the northern as well as in the southern hemisphere. Vivek, observe this particular aspect. You will understand that. The question that you have, observe this particular explanation, your question will be solved. So here, the trade winds, they will exist both in the northern and the southern hemisphere. Both of them will be moving from a direction of east to west. So that is where you will have the north equatorial current. You will also have the south equatorial current. Okay, north equatorial and south equatorial current, while induced by the shape of the coastline, the islands which are present here and the Australian coastline here. Other than that, you will have the currents being split into two. That is, the north portion will be driven further in the rightward bend as well, and then they will be driven further north. And here will be some amount of accumulated water which will roll back as a result of the rotation of the planet from the direction of west to east, which also induces a kind of a weak wind, which we refer to as the equatorial westerlies. That weak wind is also initiated by the continuous and fast rotation of the planet in the direction of west to east. So think about it. A surface is rotating continuously from west to east. So any object which is present here will also in a way follow that motion. So that is the reason behind the movement of the counter equatorial current, which sometimes also generates a equatorial westerly wind purely at the region of equator. Nonetheless, this north equatorial current here, basically, it moves just like in the case of the Atlantic Ocean. It moves here and it gets divided by the islands around Japan. And here you have the towards the western part, you have the Tsushima current, and towards the eastern part, you have the Kuroshio current. So the Kuroshio current is equivalent to the Gulf Stream that you see here. So here you have the Kuroshio current. Meanwhile, here also polar easterlies will exist. Here also polar easterlies will exist, isn't it? So these polar easterlies will induce a motion for the currents here and that or movement of water here. That water movement will then be directed by the shape of the coastline. And that is where here also you observe the bend is in the rightward direction, right? Now here, that is the Oyashio current, the cold Oyashio current, which is equivalent to the cold Labrador current here. So the cold Oyashio current will meet the warm Kuroshio current. This will also form the ideal fishing ground. It will be very good for fishing. Now, then you have the North Pacific current, just like the North Atlantic drift. This will be driven further by the westerlies. The westerlies will be dragging it towards the east. Now, this will hit the coastline here, right? It will get bifurcated into two. Now, the same ocean current, when it travels further into the higher latitudes, it will be considered to be a warm current. That is what you have as the warm Alaska current, right? And the same current, it is diverted to the lower latitudes, but the lower latitude, the temperature of water is higher. So the same current, just like in the case of the cold Canary current, you have the cold California current here, because it is the California coastline. And that cold California current then completes the circulation overall. Whereas in the case of the southern equatorial current, here it will hit the Australian coastline. It will form the East Australia current, just like the Brazil current here. It will form the East Australia current. Here also it will get subsumed by the west wind drift, which is a circumpolar movement in the Southern Ocean. This west wind drift will again deviate to the left, right? It will again deviate to the left. And here you have the very cold Peru current, or what is also referred to as the Humboldt current. So this is the Peru current, what is also referred to as the cold Humboldt current. Okay, that is what we have as the cold Humboldt current, which finishes the entire circulation. Okay, so here also you have a very ideal fishing ground, just like in the case of Atlantic. In the case of Atlantic, where was the ideal fishing ground situated? Where the Gulf Stream and the Labrador current would meet. Here, where the Kuroshio and the Oyashio meet, that creates a very ideal fishing ground. But the situation significantly changes whenever we come to the portion of the Indian Ocean. And in the Indian Ocean, the situation changes primarily because of the shape of the Indian Ocean. Now, in the case of the Indian Ocean, it is something which is closed significantly from the northwards side. Indian Ocean is closed in the northward side. Unlike the case of the Pacific and the Atlantic, if you observe the Pacific and the Atlantic, they are open, right? They are larger open oceans. Here, you have a closed scenario. So here, because the northern Indian Ocean is closed and is very smaller, so the impact of wind direction created because of the frictional drag of the wind, etc. So that is where the impact of wind movement will be very high. The wind movement impact will be exaggerated here. So that is where, with the shift of the or the change in the wind direction between various seasons, we have seen that during the months of April, or rather May, June, July, August, September, in that portion, you have the wind direction towards this. These are the southern trade winds, isn't it? So that is where the southwest monsoon. So that is where you will observe that in the northern Indian Ocean, the shape of the ocean current in the northern Indian Ocean is clockwise during the case of, or during the months of advancing monsoon or southwest monsoon. Which are the months? That is June, July, August. These are, or even September, these are the months that you will experience, even in May. Then, in the month of the retreat and the northeast monsoon, that is December, January, so November to January, February, in a way, you will observe that the wind direction has reversed here. Wind direction has reversed. So when the wind direction reverses, here the winds will blow like this, the winds will blow like this. So that is where you will observe the northeast monsoonal currents, which will be counterclockwise. So here only in the northern Indian Ocean, the ocean currents, they change their direction between the seasons because the northern Indian Ocean is closed by the land mass. So there will be a greater impact of the wind and aided by the frictional drag by the wind. That is why the ocean currents, they change their direction as the winds also change their direction. Whereas in the southern Indian Ocean, it is something which is very similar to southern Atlantic, very similar to the southern Pacific. It is only in the northern Indian Ocean where you observe these marked differences. Okay, so here basically observe that in the south equatorial current will be there. It will be divided by the Madagascar islands. So here you have the Mozambique and the Agulhas current. It will be subsumed by the west wind drift. That west wind drift will again divert here. So earlier you had the Peru current in Pacific, you had the Venezuela current in the Atlantic. Here you will have the cold West Australia current. That will be the cold West Australia current on the western coast of Australian continent. So that is how you have this circulation. The Leuven current that you see, this is a very minor current. So this is a very minor current which you will observe. This Leuven current will be bringing waters from the region of the Pacific very slowly and steadily into the portion of the Indian Ocean. So that is where you will find the weak Leuven current, which will help in mixing the water from one region to another. Okay, right? Write it down. What write it down? What do you want me to write down, Gaurav? Do you have a pen and paper? Kindly take notes. Okay. Eventually, you will have to write it down on your own when the question comes in the exam. Uh, in Pacific Ocean, if the winds are going from east to west, interacting with each other, so are you talking about the counter equatorial current, Sakshi? So that counter equatorial current is very weak. It is almost negligible. And that is aided by the movement of the planet. So here, many of the times the winds in the region, we have discussed in the case of the doldrums as well, that it is not as if the winds will collide and then rise up in a portion. The winds will have a flow around the region of equator exactly. You don't have much of a wind flow. So that is where you have the counter equatorial current. Okay. November to February. So, okay, how many of us have not had any revision about the portion of monsoon? We have simply attended the portion of monsoon. We are happy that monsoon is getting over. We are happy that the geography sessions are getting over. So let's enjoy that. So I hope we are able to understand that in the case of the Indian Ocean, in the case when we talk about the Indian Ocean, Northern Indian Ocean in particular, we have the reversal of winds. The reversal of winds happens between various seasons. So, in the case of the Northern Indian Ocean, here, in the case of the Northern Indian Ocean, winds reverse their direction. That is what is the monsoon. Winds reverse direction. So during the months of, when we talk about the months in general, so months of June, in fact from May itself, June to September, what is the direction of wind movement? Southwest to northeast. During the months of November to February, the wind direction is northeast to southwest. Why? Because of the shifting of the ITCZ. The ITCZ comes towards the region of equator, and these are basically your normal trade winds of the Hadley circulation. So that is why you have this kind of a circulation. Is that understood now? And why does it revert their direction? Because of the shifting of the ITCZ. Voice is breaking. Rashida, it might be because of the pain that I see on the type of questions. That is why. West wind drift overall in the southern hemisphere, Kumari, is because of the aspect of the uh, around the region of southern ocean. You have the presence of westerlies, and these westerlies will drag it, and that is why it is west wind drift. Okay. March, April, and May. March, you will still have the motion in the in this particular direction, right? Here in the month of March, the movement is slightly weakened. Does Leuven current help Bay of Bengal create low pressure? Sometimes, not always, sometimes, Basu. And tomorrow is class or not? No, tomorrow is not a class. How counter equatorial current develops? Counter equatorial current is developed as a result of the circulation, or rather rotation of the planet. So rotation of the planet drives the accumulated water around the region of equator along the same direction as the rotation, and that is what is referred to. Let me write it down so that yes, you will get the entire notes in in the additional reading material. So when we talk about the counter equatorial current, no, the circular portion or the circulation in the middle of the ocean, they are not cyclones. They are what are referred to as eddies and a part of the Rossby wave. Okay. So here, when we talk about the counter equatorial current, they get generated. So the north and south equatorial current lead to the accumulation of water across the western coast of the continents. Okay, accumulation of water across western part of the oceans. So here, what it leads to is this accumulated water is influenced by continuous rotation of planet from west to east. This induces a movement, a weak movement of water from west to east. That is counter equatorial current. Is that understood now? It is this rotation, by the way. Remember, we had studied MJO, Madden-Julian oscillation. If you can recall, sometime in the past life, you had studied the portion of Madden-Julian oscillation. I don't expect you to remember in this life, but sometime you have studied that. So there also we had seen a west to east translation that is also aided by the rotation of the planet, right? So here, this also aids rotation, also aids a very weak movement of air at equator from west to east. These are known as equatorial westerlies. These are referred to as equatorial westerlies. I hope it is understood now. May you slightly elaborate the part of Pacific Ocean current after East Australia current? Okay. So basically, even in the case of the Southern Pacific, the movement is same as you observe in the case of Southern Atlantic. It is same as you observe in the case of the Southern Indian. Here also you will observe the East Australia current will also bend slightly to the leftward. Now here it will get subsumed by the circumpolar movement. Excuse me. So here you will observe a kind of a circumpolar movement, that is the west wind drift, which is present in the Southern Ocean. And I have written here already that it is induced and aided by the westerlies. So that is where this Australia warm East Australia current will be subsumed. Furthermore, as you move to the east, this warm Australian current will get deviated and diverted to the left, and that will form the cold Peru or the Humboldt current. Okay, I hope that is understood. Now we come to the portion which is a part of the global circulation of the entirety of the oceanic water, and that is the global conveyor belt or the global oceanic circulation. One part of that global oceanic circulation, which exists in the region of the Atlantic, is referred to as the Atlantic Meridional Overturning Circulation, what is also referred to as AMOC. Okay. So, what is this global circulation? So, when we talk about the various different oceans, so the oceanic water, they are not isolated from each other. They also keep on mixing with each other. So these oceanic waters, you will find they induce a kind of a thermohaline circulation where this particular portion, warmer waters will go to the higher latitude, they will sink, they will come back, and they will move at a deep subsurface. And wherever they get heated up, they will again rise, move as a surface current. And that is how the heat and the nutrient across the entirety of the globe that will get circulated. So this is the global oceanic circulation. Global oceanic circulation. So that basically means that this oceanic circulation is also going to help in distribution of heat and distribution of nutrients across the oceans of the world in general. Now here, even though the image is not very accurate here, this is just a schematic representation. This warm current that you see, this is actually Gulf Stream. So Gulf Stream, when it reaches to the northern extent to the higher latitude, some part of it cools down, and then as a result of the thermohaline circulation, it reverts back. The portion of this global circulation in the region of Atlantic, that is what is referred to as the AMOC, Atlantic Meridional Overturning Circulation. So the global conveyor belt, are we aware about the meaning of the term conveyor belt? Any of us who is not aware about the meaning of the term conveyor belt? Okay. Conveyor belts, basically, you would have seen in industries, in floor mills, even in the case of the walkways, escalator, where you have in the malls, you would have gone, seen the escalator. This is a conveyor belt where it is having a motion somewhat like this. Is that now something that you can recall? The walkways, etc. Yes, the airport belt, also take that also. Anything, right? So now you are aware of conveyor belt. So conveyor belt basically represents a kind of a circulatory motion. So that is why the global conveyor belt, yes, like a treadmill. Okay. Now, here, global conveyor belt is a system of ocean currents that transports water around the world. While wind primarily propels surface currents, the deep surface currents or the deep ocean currents are driven by the thermohaline circulation. They are driven by the thermohaline circulation overall. Okay. Now here, the density depends on the, so thermohaline circulation is driven by the factor of density, driven by both the temperature and salinity. Along the conveyor belt, heat and nutrients are moved around the world in a leisurely 1,000-year cycle. So, in order to complete one entire circulation across all the oceans of the world, it will take close to around 1,000 years. We have been able to monitor this only for the past 100 years or so. Right. Now, the portion of the conveyor belt which is present in the region of Atlantic, that is AMOC. So, the Gulf Stream is a part of the Atlantic meridional overturning circulation. As warm Gulf water approaches the North Atlantic, it cools, releasing its heat to the atmosphere. As it cools, the water becomes more salty and dense and sinks to the bottom of the ocean. The Gulf Stream and AMOC are a part of the larger process of thermohaline circulation. This describes the interaction of surface currents like Gulf Stream and deep, slow moving underwater currents, which helps to mix ocean waters, salts, and even organisms on a global scale. As ocean temperature and density contribute to temperature change in the atmosphere, conveyor belt also contributes enormously to the climate of our planet. Now, why have we covered this is primarily because this has been in news significantly. This has been in news because of the various different news reports that the AMOC or the Atlantic portion is slowing down. So the Atlantic portion is slowing down means that circulation that you see, the thermohaline circulation that you see. So the thermohaline circulation will be like a conveyor belt. Let's suppose we consider this to be the Gulf Stream. Gulf Stream moves to the higher latitude, cools down, salinity increases, density increases, you have a flow. Now, what is happening is that understand why it is slowing down. So, what actually happens is that due to global warming and climate change, the polar region, the temperature of the polar region is also increasing. As the polar region begins to heat up, as the polar region begins to warm up, so in that situation, what do you think will be the condition here? Here, why is it that the currents are sinking or the water is sinking? Because the water is becoming very cold as it comes to the polar area. Some portion of it gets frozen, salinity increases, hence it is sinking down. But if the temperature at this portion increases, let's suppose, that means the water won't cool down anymore. The water will continue to stay warm itself. When the water continues to stay warmer, then what will happen? Will it sink? It will not sink. So, due to global warming, the Gulf Stream portion is not sinking at the same rate anymore, due to which you have a slowing down of the AMOC. So, due to global warming, AMOC is slowing down. Now, when AMOC is slowing down, that means it will lead to a kind of an inefficient translation of heat from the lower to higher latitude. It will also lead to the inefficient movement of the nutrients from lower to higher latitude, isn't it? And also, as the AMOC is slowing down, what do you have? You will have the condition that the water will stay in the same region for a longer period of time. So if this entire circulation is broken, water stays in the same region for a longer period of time. Means in that area, water will get significantly heated up, isn't it? Water will get significantly heated up. Now, once the water gets significantly heated up, what will happen to the temperature there? What will happen to the temperature of the water? If it remains in the same region, it gets heated up, its temperature will rise. And once the water temperature rises, what kind of phenomena do we experience? We experience cyclonic events. That is one of the reasons why northern Atlantic is experiencing significant amount of cyclonic events. That is also one of the reasons why northern Atlantic is heating up at an exorbitant rate. Okay, so it will have an impact across the entirety of the oceanic area as this amok slows down. Yes, ice will also melt. Good. Now, we come to the impact or the effect of ocean currents. So, when we talk about the ocean currents, so mixing of warm and cold currents help to replenish the oxygen and thereby favor the growth of planktons, that is the algal species, the primary food for the fish population. So, that is where the fish population increases. So, the best fishing grounds of the world are mainly these mixing zones where you have the mixing of the warm and the cold ocean currents. Those are the best fishing grounds of the world. Then, here, cold ocean currents, they are also responsible for the creation of deserts in the western part of the continents. So, if I take you back, basically, observe here also you have the cold West Australia current, here you have the Victorian desert. Here also you have the cold Peru current, here you have the Atacama desert. Here you have the cold California current, here you have the Mojave desert. Then here also you have the Beniguela current, you have the Namib Kalahari desert. So the cold ocean currents, they end up creating a kind of a desertified region. And what is the reason for that? So think about it, apply your logic. You know this already. So let's suppose we consider this land area. So here, let's suppose we consider water. Let's suppose the water is very cold. Very cold in the sense much colder than the average temperature at the same latitude. So what will happen to the air here in this region? What will happen to the air? Air temperature, will it be warm or will it be cold? The air temperature will also be cold, influenced by the cold water. So here air temperature is cold. Air temperature. Now, if the air temperature is cold at the surface, what kind of atmospheric condition will it create? Can we say it will create a condition of temperature inversion? Can we say it will create a temperature inversion? Right? So, this creates temperature inversion. Temperature inversion. And whenever you have temperature inversion, what happens to the probability of rainfall happening in that area? That reduces. So hence, little to no rainfall. No rainfall. Okay. So here you have little to no rainfall, which is observed in this area. So that is why you have the deserts. So, be it in the region of the West Australia, you have the Victoria Desert. Be it in the region of the California current, you have the Mojave Desert. You have the various different deserts, Chihuahua Desert also. Then, be it in the cold Peru current or the Humboldt current, you have the Atacama Desert. Then, Beniguela current also creates Kalahari and Namib Desert. So, you have the creation of these desert like features. Okay. No, Thar Desert, it why will Thar Desert be impacted by the ocean current? Thar Desert is very far away. So Thar Desert is not on the coastline, is it? So that is why Thar Desert, we have already discussed why the region of Thar is a desert, and that is because of the alignment of the Aravallis. Okay. Now, why temperature inversion? Because here you have the cold air at the bottom and warm air at top. So that is the condition of temperature inversion. Why cold and warm currents are intersecting at the coast of Brazil? So Falkland current will deviate to the leftward direction in the southern hemisphere, and warm Brazil currents are coming from the north. That is why they will mix. Okay. Now we come to the portion of Sargasso Sea. So Sargasso Sea was basically, it is a region of absolute calm in the northern portion of the Atlantic, that is in the tropics of the Atlantic. This converges with the subtropical high pressure belt. Subtropical high pressure belt, that is the horse latitude, means will you have rainfall there? Almost negligible amount of rainfall there, right? Now, it was something which was discovered way back in the 15th century when you had the Portuguese sailors, when they were moving across the Atlantic to discover the newer areas and newer lands. They came across this region where water was absolutely calm, was not moving at all. Now, the water was calm, and in those calmer waters in the oceans, you had the growth of seaweed. So, this was the growth of seaweed. Okay, this was the growth of seaweed. So from top it appears like a brownish cover. It basically is a brown algal species. So that is the brownish appearance, and the cross section appears like this. While this is very good for the biodiversity in the region, it can be a nightmare for navigation and shipping, in the sense that if you have to carry out shipping in that region or navigation, the movement of ships, oftentimes these weeds, they get entangled in the propeller of the ships, the hull of the ships, and that is where the ship experiences breakdown and it lies stagnant in the same region. So these seaweeds, they were referred to as sargassum in Portuguese. So they are referred to as sargassum, and hence the name which was derived was Sargasso Sea. Okay. Now, why is it that basically you have the creation of a condition of calm? That is because of the subtropical high pressure belt, and also aided by a complex phenomena that is referred to as the Ekman spiral. You don't need to go into the detail of that, but basically here what you will observe is that the ocean currents, in a very simplified form, if I try to tell you, the ocean currents, they will be moving aided by the wind movement and also aided by the Coriolis force. There will be movement, there will be movement, there will be movement, but eventually the movement will reduce. As we move towards the center, the movement will reduce. So that is why in the central portion, all around it, you will have circulation, but in the central portion, you will have the calm. So that is why it is said that the Sargasso Sea is the only sea which is not surrounded by land. Any other sea that you consider, it will have one or the other land boundary. Sargasso Sea is not surrounded by land at all. In the north, it is surrounded by the North Atlantic Drift. It is bordered by the North Atlantic Drift in the north. In the west, it is bordered by the Gulf Stream. In the east, it is bordered by the Cold Canary Current. And in the south, it is bordered by the North Equatorial Current. So it is bordered by the various different portions of the Atlantic Ocean, driven by the various different oceanic currents of the Atlantic Ocean. But here, you have an absolute calm condition. Okay, that is why the seaweeds, they grow in significant proportion. These seaweeds, while they are a nightmare for navigation and fishing, these seaweeds, they also significantly help in the biodiversity of a region. They can be used for medicinal purposes. There is great amount of research being carried out for the medicinal utilities of the seaweeds as well. Okay, sargassum is Portuguese for seaweed. Okay, it was the Portuguese sailors, and in fact, even the ocean current, Gulf Stream, etc. All of these were initially discovered by the Portuguese themselves. These were the sailors who would go through the entire region of the Atlantic. Sometimes, if you get an opportunity to read about the activities of the merchants and the sailors during the 15th, 16th century, your mind will be boggled by the bravado that they had to go into uncharted territories with very little amount of resources. They would be given some amount of resources by the government, by, in many of the cases, the churches, and they would be asked to explore newer areas. And all of them would, they would venture out into the sea. They would bring whatever they could. Many of them would die and perish in the sea itself. And it was during these journeys where eventually the Spanish Armada also followed. And that is where it was during these journeys that we got to know about the planetary wind system, about the oceanic circulation system, about the features of the oceans as well. Okay? Now, then, what causes the seaweeds? So, the calm conditions, the lack of any movement in the oceanic water, that creates the condition for the growth of seaweeds. Okay. Now, despite high temperature at deserts, they don't receive rainfall. No. So, only high temperature will it be sufficient for rainfall? Don't you need the availability of moisture for rainfall? So here moisture can be gained from where? From the surrounding ocean. But in the surrounding ocean, you observe what? Temperature inversion. So how will you get rainfall? So now we come to the portion of coral reefs. Before starting it, only I will tell you that we will discuss, or whenever you have the environment session, wherever you attend the environment session, you will be discussing in detail about the coral reefs, what species they are, the symbiotic relationship, etc. Here we are going to discuss about the basic geographical aspect of coral reefs. Now, coral reefs, they are also referred to as the rainforest, tropical rainforest of the water ecosystem or the marine ecosystem. Now, these coral reefs, they basically present a kind of a beautiful, picturesque scenario underwater. Now, these are made up of all these reefs. They are made up of individual organisms which we refer to as coral polyp. Coral polyp. Okay, they are known by they individually they are made up of coral polyps. Now these coral polyps, they are very simple organism. These are animals, by the way, where you will find these organisms having a simple digestive tract, a simple digestive system. So here basically you will have the digestive mechanism. Right. Now here you will have the tentacles. These tentacles are there to capture food and catch food. And on these tentacles, you will find the presence of many smaller organisms of algae, what is referred to as the zooxanthellae. That is a symbiotic relationship, mutually beneficial relationship. Here you have the algae, that is zooxanthellae. Okay, that is what the coral reefs they constitute of. So basically, if you observe this, it is a kind of an underwater ecosystem characterized by the reef building corals. Reefs are formed of colonies of coral polyps held together by materials such as calcium carbonate. Calcium carbonate is calcium and carbonate, all these ions are present in the oceanic water. So when we talk about calcium carbonate, so they are held together by the presence of calcium carbonate. And why? Because the coral polyps, they synthesize the calcium and carbonate ions present in the oceanic water, and they build a very hard stony exoskeleton around them. That is why they appear whitish in structure. So that, because calcium carbonate is also whitish or brightish in structure. So here, these coral reefs are built from stony corals whose polyps cluster in groups. The largest coral reef is the Great Barrier Reef, which spans for a distance of close to around 2,600 kilometers, something which can be visualized from the space as well. So corals are basically an ideal represent. Not all the corals, by the way. Warm water corals. Warm water corals are the idealistic representation of what we refer to as the condition of or the mutualistic relationship between an animal and an algae. So here, this is your coral polyp. Coral polyp. Okay, so this is a kind of a symbiotic relationship which is mutually beneficial for all of them. So while the algal species, they get a platform and availability of nutrients such as calcium carbonate where they can grow and they can thrive, the corals in turn, they generally, they don't get adequate amount of food because these corals, they cannot move. They are fixated at the same place. So basically, as they are fixed at the same place, they rely on the movement of the tentacles to capture food. Now, many of the times the food is not enough, but these zooxanthellae, which also impart the different coloration that you see in the corals, they are able to carry out photosynthesis. So this is, they carry out. Yes, this belongs to the species Cnidaria, the branch of species that is Cnidaria. Corals are animals, my dear friend. So here, carry out photosynthesis. Don't worry about the portion of corals in detail. You will study in environment and ecology. Time and again, I'm telling you, don't fret about it. You will study in significant detail what are the conditions required, why coral bleaching happens, everything you will study in detail. Okay, so they carry out photosynthesis. That photosynthesis which is carried out, so here, this is helps in providing food to the corals. Okay, so that is okay. Many of you, you have no clue whether the corals are animals or plants in general. So these, okay, so let me talk about the basics once again. So all these that you see, these are what are referred to as corals, right? Now, the different coloration that you see, that is not of the corals themselves. Corals themselves, they are stony white in appearance. If you take a look at the original shape, this or original coloration, this is the original coloration of the corals overall. It is given a color because of the presence of the symbiotic algal species that we refer to as the zooxanthellae. The zooxanthellae is able to manufacture food, and that is why symbiotic relationship is what? Symbiotic relationship is when a relationship exists between two organisms where both organisms, they benefit out of each other. That is what is referred to as a symbiotic relationship. Okay, so these corals are actually animals. They belong to the branch of species which we refer to as Cnidaria. The branch of species which is referred to as Cnidaria. They are fixated to the ground. They don't move across the ground. These are the animal species which gets fixed to the ground. So these species have the ability, the common body morphology is somewhat like this, where these species, they have the ability to synthesize the calcium ions and also the carbonate ions, and they make calcium carbonate, CaCO3. So that calcium carbonate, they utilize it to build that stony white exoskeleton around them and also fix themselves on the ground. Many of these coral species, they have a lifespan of hundreds and even thousands of years. So they live for a very long period of time. They can exist underwater, but where underwater? So you have the categorization further into warm water, cold water corals. But when we talk about the warm water corals that we are referring to right now, they will always be in existence in the shallow region where the water is not very deep. Why? Because they need the availability of sunlight. Why? Because with the availability of that sunlight, that is what is utilized by zooxanthellae, and that is where the zooxanthellae, they carry out the photosynthesis to manufacture their own food. Okay, so that is why they will always grow in shallow marine waters. They grow in shallow marine waters. They don't grow in fresh water or muddied water. They require clear water. Average consistent temperature, consistent temperature around 24 to 26 degrees Celsius. Because all the marine species in general, they have a very little thermal tolerance. Why? Because historically, for millions of years, they have been living in the region where the temperature does not change drastically. We have seen that the temperature changes drastically over the land, but the temperature never changes drastically over the water body. So, because the water body always exhibits a kind of a consistency in temperature, that is why all the marine organisms, most of the marine organisms that you will encounter, they suddenly get distressed when the temperature changes anymore. So here, these corals, they require these kinds of conditions. The warm water corals we are talking about. We are talking about warm water corals. Okay, so the zooxanthellae, they get the benefit of availability of nutrients such as calcium and carbonate from the corals, because the algal species, they will require nutrients to grow, and the coral in return gets food by the food manufactured, the organic matter manufactured by the zooxanthellae. It is a zooxanthellae which gives the coloration to the corals, provides coloration to corals. So all these vivid colors that you observe, these are the different species of zooxanthellae. That is why you have these colors. Okay, so they will always be found in shallower waters. Now, when the zooxanthellae carries out photosynthesis, the byproduct will be what? Organic matter and oxygen. So they provide oxygen into the marine waters, and also food in form of organic matter. Now that is why these corals, they are able to house a very large variety of biodiversity, and it is because of that reason that they are also referred to as the tropical rainforest of the marine ecosystem. Because the rainforest, they also manufacture oxygen, produce oxygen as a result of photosynthesis, and the rainforest, they also have the ability to house a large number of species. So something on the very similar scale will be observed in the corals as well. There are deep sea corals as well, there are cold corals as well, you have the black corals as well, where you don't have the symbiotic relationship at all. Okay, now these corals, where basically many of these corals, they will exist for hundreds of years and thousands of years, and in that time they will build a calcium carbonate exoskeleton around them. When they die, they will leave behind that calcium carbonate exoskeleton. So let's suppose you have this as the level of water. Again, I would say corals are fixed. Corals do not move. That is why they have the calcium carbonate. I understand it is almost impossible for you to imagine an animal which cannot move, but these are the animal species which cannot move. You would have come across Hydra as well, the species of Hydra, right? All these, is it that the school syllabus has changed very drastically Since we graduated or we moved from school, is it that the school syllabus they have removed all this? Or is it still taught in the 7th, 8th, 9th standard? Animal Kingdom you would have studied? Class 9, yes. If I am able to recall the portion of class 9, I'm sure you guys would have attempted class 9 after me, right? So please, so either in ninth or 10th, it would be there, isn't it? Right? So basically, coming back to it, when we talk about these here, let's suppose this is the base, or let's suppose we consider the coral ecosystem here. Now, these corals, if they grow here, they will leave behind a kind of a thick calcium carbonate exoskeleton behind them. And by the way, guys, please don't get disheartened if you don't remember these things. It is absolutely possible that we have not paid much attention in our school days and school classes. It is absolutely possible we don't remember much of it. Please don't get disheartened. The solution to it is to pick up those books of class 6 to 10th of NCRT basic science. Just flip through it. Okay, just flip through it. You don't need an advanced reading of graduation level science, etc., but that 10th level science, you should not be relying on the science and tech classes for that. That basic information, if you have, it will help you not only in your UPSC journey, it will help you correlate and understand many of the perspectives. Many of us, I have seen that we have problem in understanding what is melting, what is boiling, what is latent heat of condensation, vaporization. We have problem in that. So don't have any ego in yourself. Don't wait for someone to teach you that, because these are for the 6th, 7th, 8th, 9th standard. I'm sure you would have been, or you are one of those who has already completed those sessions. So kindly go back and pick up those books one by one. Pick up those books, and at this stage of your life, you will be able to complete those books maybe within a week or 10 days if you go for a dedicated study. But the kind of confidence boost that it will give for many of you, I see, and many of you do require that confidence boost. So do that. Be ready to put in the hard work. Okay, this is the civil services examination. It requires hard work. Put that hard work. There won't be any disadvantage whatsoever. Okay. Now, these are basically the ones which have died. Now, after they have died, the next generation of corals will utilize this base of calcium carbonate to grow furthermore. Okay, they will grow furthermore on top of this. Now, while they are growing, these will also synthesize calcium carbonate from the surrounding, and they will also deposit them. Then the further generation will also do that. Then the future generation will also do that. It will continue to happen. It will continue to happen. Eventually, it happens up till what point? Eventually, it will come above. All these are the calcium carbonate exoskeletons left behind by the previous generation. Calcium carbonate exoskeletons left by previous generation of corals. Okay, so they will continue to grow, and here, yes, Shubham, exactly like that. So it will continue to grow, and the corals will continue to grow on top of that till the point that these come above water. The moment they come above water, that is when they will die, because after all, these are marine species. These cannot even survive in river water. They will be surviving only in marine waters. And these are the various different marine species out there. Now, the moment it comes above water, then few of the interesting things happen. So once they die here, so you are left with a kind of an island of sort formation with the rocks dominant in calcium carbonate. Can we say that this will be dominant in calcium carbonate? We can say that, isn't it? Now, this calcium in general is whitish in color, right? So here, this calcium carbonate will get degraded, eroded, etc. You will have the formation of white sands in this region. Significant amount of white sands you will observe in this region, isn't it? Now, it might be possible that a traveling bird would be moving through here, dropping some of the seeds, taking shelter. The migrating birds, which move for thousands of and hundreds of kilometers, they might take shelter here. When they take shelter, they might drop a seed or two. Few of them might germinate in the conditions of moisture and sunshine. And you will have what? You will observe within a few, let's say, hundreds of years, you will end up observing the growth of trees and plants in this area. You will observe the growth of trees and plants in this area. So, like this, what do you end up finding is a kind of a creation of an island. But this island has been created purely because of the corals, right? This island has been created purely by the existence of the corals. So, such islands are referred to as the coral islands. Okay. For example, you have the Maldives, you have the Lakshadweep region. You will also observe the growth of certain mangroves in this area, mangroves across the coastline. And you will have the development of the coral island. This is what is a coral island. So, example of coral islands. So, that is basically coral islands. So, this example you have Lakshadweep, Lakshadweep, Maldives. Now, in all these areas, you will notice one particular fact. And that fact is that the sand in this region will be whitish. It will not be the brownish sand that you generally encounter. Certain areas you will have the brownish sand brought by the sea wave, which will bring the brownish mud and sediments and sand in the coastline. But generally, in these islands, you will find whitish sand to be predominant. Why? Because it is formed by the disintegration of calcium carbonate. Bahamas also, many portion of Bahamas, Caribbean also. Okay, so that is what is the coral islands. Mostly coral islands are in tropical regions, Kumari. That is because these are the warm water corals that we are talking about. And it is only the warm water corals which eventually over thousands of years will form these coral islands. Okay. So these are the areas where you have the coral islands. So the region around Indonesia, Philippines, Australia, then Solomon Islands, Papua New Guinea, Malaysia. These are the areas which contribute or have more than one third of the coral population across the world. And that is why it is also referred to as the coral triangle, right? Where you have significant amount of coral population. In India also, in that entire stretch from Lakshadweep to the region of Maldives, you'll find significant amount of corals. But you will not find these corals in the region where there is lot of mud. There you will not find it where you have lot of sediments. They will grow in clear saline water or clear marine water. Why? What if there is pollution and mud? Why won't it grow there? Because in those conditions the sunlight gets blocked and the zooxanthellae population that dies. Once the zooxanthellae population starts dying, then the corals are reduced to their stony white structure themselves, and that is what is referred to as coral bleaching. So coral bleaching happens. Bleaching is what? A whitening, bleaching is something that you would have carried for your, let's suppose in certain cases, your bedspreads, for suppose your table spreads, you carry out the bleaching. Now what is that? That is a whitening activity. So sometimes due to adverse circumstances or conditions, you have the zooxanthellae population which escapes these coral polyps, which dies also, and that is where the corals are left without zooxanthellae. They can survive like this for a few days, for let's say a few weeks. But if the conditions don't revert back to normalcy within 45 days or 60 days, that is when the corals they die because of lack of food. So that is where coral bleaching leads to mortality of the corals. Leads to mortality of corals. Okay, they start to die, right? So when basically the zooxanthellae population is now, why will it escape? Let's suppose suddenly the temperature has risen, there is a sudden marine heat wave which has been created, the zooxanthellae will die. Let's suppose there's a disease, zooxanthellae can die. Let's suppose there's solid waste dumping or pollution, marine oil spill, zooxanthellae will die. So any of these adverse activities will lead to the death of the zooxanthellae. And once the corals they die, the entire marine ecosystem is impacted so significantly and so heavily, because once the corals are dead, means what? Means there won't be any more supply of oxygen in that area, means there won't be any more organic matter to be produced in that area. So it is a disaster for the aquatic ecosystem, right? Now, these corals, depending upon where they are found to be in existence, they are divided into, these corals, they form reef. So they are divided into fringing reef, barrier reef, and atolls. Basically, it is dependent upon where they are growing. So generally, we have seen that how is it that new land gets created in the ocean? And here, understand this entire process is worth millions of years. So new land gets created due to volcanic activities. It can happen that after, let's say, volcanic activities have stopped, you have a volcanic island or an island in between. So in those areas, in the cases of the islands, on the sides here, you will observe the growth of the coral population and the coral species in the shallower waters. So when you observe the growth of the coral species in the shallower waters, these are on the fringes of the land, hence the fringing reef. Now these develop, the individual polyps, they will develop the calcium carbonate exoskeleton, they will fixate themselves to the ground. Now let's suppose over a period of hundreds and thousands of years, the land begins to subside due to endogenic forces. We have seen that the land can get uplifted, the land can also subside. So let's suppose the land begins to subside, the land begins to sink. As the land sinks, the coral which had built a calcium carbonate exoskeleton fixated itself, it will stay where it is. But the land has started sinking. So there, water will come in between. A small lake-like portion will be created. A large water body might get created. And you will have many of the coral islands in existence. This forms a kind of a barrier around the land, and that is what is referred to as a barrier reef. Let's suppose this subsidence continues and the entire land has then sunk. You are left with nothing but the coral islands. That is the atoll. Okay, so here fringing reefs, they are formed along the coast of the continents or islands. Their surface is connected with the coast and rises to the low tide water level in a rugged and uneven platform. So it is on the fringes of the landmass, on the sides of the landmass, right? Observe, they have fixated themselves to the ground here. So if the central portion after some time will sink, this will continue to stay, right? Majority of the corals that you find, they belong to this category, warm water corals. That is why you will find all these corals situated around the islands, where you have shallower waters, right? So that is where you have the fringing reefs. Then, as the central portion continues to sink, why will the central portion sink? Not always will it sink. Sometimes it sinks due to endogenic forces, due to what we refer to as the diastrophism as well as the aperogenic movement in particular. So here, as the central portion sinks, the portion of the corals gets left behind, and you have water which comes in between. That is the barrier reef. So they are situated away from the coast, and in between the coast and the reef, there's a relatively wide and deep lagoon. The reef is called a barrier reef. Now, when that sinks further, you are left with a chain of coral islands, generally in a horseshoe shape or a circular shape, which we refer to as an atoll. Right? So these are the most common type of coral reefs and are roughly circular or horseshoe shape. Now observe this image here. So here, basically, you will observe the whitish portion here, the whitish substructure present here. Why is it so? Now, this is something you would have seen any of your friends moving to Maldives, posting the pictures on social media. You would have observed water appears very blue, turquoise blue. Here also it appears turquoise blue. And here the water is dark, dark blue. Here it is very light blue. Why? Because these are the exoskeletons of calcium carbonate. Calcium carbonate is whitish in color. That creates a reflection. That is why the water gives you that appearance. It is not as if the water is very clean here. It can be, but basically it is because of the calcium carbonate. So that is the corals and the growth of the coral. So overall, if you take a look at the entire chain formation, it is not greenish, it is what is referred to as a turquoise blue color. So initially you have a land created due to volcanic eruption from underwater. Now over a period of time, you will observe the fringing reefs to develop. The central portion of the land, let's suppose it starts to sink, right? It sinks further, creates a barrier reef, right? So wherever you find barrier reef, at one point of time it would have been a fringing reef in general. That means the land in between has moved down. Then if everything sinks, you are left with a kind of a chain of islands, that is an atoll. You will find such atolls even in the region around Maldives, right? You will find these atolls in existence. So the corals are very, very important and relevant because they will support the wildlife in that area, the biodiversity in that area, a lot of fishes, tourism sector, and these corals, they also have medicinal benefits. So they are very important. Overall, they support close to around 500 million people. They earn their livelihoods due to fisheries, due to tourism, and all the direct and indirect benefits associated with corals. Okay. In Lakshadweep, you have a few islands which are example of atolls. Yes. Okay. Now, after this, we come to the questions. If we can, let's take a look at few of the questions here. So here, what is the reason for not mixing up of water at confluences? Because the water have individual different properties of salt presence, of temperature. That is why. Now, consider the following statements. In the tropical zone, the western section of the oceans are warmer than the eastern sections owing to the influence of trade winds. In the temperate zone, westerlies make the eastern section of the oceans warmer than the western sections. So I'll give you a massive hint. Yes, Karvit, correct. Can we go on to purchase the property as it will subside? In all fairness, the property and the acquisition of property is very difficult in the regions such as Lakshadweep. Good. So here you have to indulge in the portion of which section are we talking about? So here the principle involved is downwelling. Downwelling is involved. So downwelling means you have accumulation of water. So western section of oceans in the tropical region. So western section. So if this is an ocean, so western section, eastern section. So trade winds will carry out downwelling here. That will lead to a rise in sea surface temperature. So the first portion is correct. And then in the temperate region, you will have westerlies. Westerlies will carry out downwelling here, right? So that will increase the sea surface temperature. So both of them are correct. So the correct answer is C. Okay. Then this is an easy one. The most important fishing grounds of the world are found in the regions where warm and cold atmospheric currents meet, rivers drain out large amount of fresh water into the sea, warm and cold ocean currents meet, continental shelf. Of all the types of questions that you can ask, you are asking the question that where is the stomach of coral polyp? Okay, the brown section that you saw in the image of the corals, that is the stomach. Yes, all of you are correct in this. I would be very interested to know who gave the incorrect answer in this. So, where you have the warm and cold oceanic currents meet, that is where you have the ideal fishing grounds of the world. Tides occur in the ocean and seas due to which among the following? Gravitational force of the sun, gravitational force of the moon, the centrifugal force of the earth. Correct. Yes, correct. Matlub, it increases the dissolved oxygen because it increases the interface property of the air and water. Gayatri, wrong. So here you have 1, 2, and 3. All of them are responsible. Consider the following statements. Most of the world's coral reefs are in tropical waters. More than one third of the world's coral reefs are located in the territories of Australia, Indonesia, and Philippines. Coral reefs host far more animal phyla, that is, animal species, than those hosted by the tropical rainforest. So, here, take a calculation here and then think about the answer. Atolls are generally on the outside, you will find it very deep, but in the central portion, not very deep. Yes, Garvit, correct. Tarun, correct. Good. Maria Vivek, incorrect. Other Tarun, also correct. Manikandan, correct. Aman, good. So here, majority of you have given the incorrect answer. So while the first two statements are correct, that the most of the coral reefs are in tropical waters, more than one third are located in the territories of Australia, Indonesia, and Philippines. The coral reefs don't host more amount of animal phyla than the tropical rainforest, because in tropical rainforest, if you consider the insect species, the butterflies, all of those species, the avian species, the arboreal species, the variety is much more. Okay. Now, this was a question of 2017. At one of the places in India, if you stand on the seashore and watch the sea, you'll find that the seawater recedes from the shoreline a few kilometers and comes back to the shore twice a day. And you can actually walk on the sea floor when the water recedes. This unique phenomena is seen at. Now, I've told you the answer of this in the session itself, so it will be easy. Yes, correct. All of you are correct here. So I think there are three Taruns in the class, is it? No, Usha Sri, incorrect. Right. Uni, incorrect, my dear friend. Good. So here it is Chandipur in Odisha, which is the correct answer. Then we will come across the subjective questions. Later on, we'll take a look at it next week. Okay, why tropical rainforests are in? Because in tropical rainforests, you have far more number of species. Okay, so right. So that is where we will end the session here today. That is where we end the portion of physical geography. We end the portion of the world as well, right? Because now you know the climate of the world, geomorphology of the world, oceans of the world, circulations of the world, climatic conditions of the world. Now, from Monday onwards, we enter into the portion of knowing our country in a better way. We enter into the portion of Indian geography from Monday. So that will be all from my side. And we don't have an extra class tomorrow. Map pointing, we don't have time today. So we'll take the map pointing later on. So this is the leaderboard. Okay. Uh, okay. Right. Now, no, Gaurav, it is important to read the newspaper as well. You can revise with the magazine. Okay. So that is where we'll restrict the session. And Subramania, I attend both evening and morning batch. So after next month, completed subject once again repeats according to the timetable. In that time, is it better to revise complete subject until? Is it better to join another batch for new subject? Revision, if it is not carried out, my dear friend, there is no point. Attending sessions without carrying out revision will be leaving you very blank face. So if let's suppose you have completed a portion, if let's suppose you have forgotten an earlier portion, then you can join the fresh batch once again. Okay, but ideally I would recommend that if you are attending morning evening sessions, after the morning session revise, after the evening section revise. Okay. Okay, Anurag, I'll take a look into it. Yes, human geography, that is from Monday, we will start the portion of Indian geography. There we will study human, economic geography, all of them. Okay. So that is where we'll end the session. Thank you guys for humble and patient hearing. Any doubts that prevail, you can contact us. And till we meet again on Monday, take care of yourself. Good night. Goodbye. Thank you. Yes, this PPT is enough for mains and prelims, at least for oceanography, yes, for all the units.